everybody. For the start. Sorry about the late start, guys. But we're still gonna complete the task of today. Right? Which is to go through. It's a bank of questions. I'm gonna be doing it topic by topic. I'm gonna start with sets today. The reason I'm starting with sets is that sets is not a topic on paper 2, it's a topic on paper 1. Right? It's not a topic, it's not a topic on paper, it's a topic on paper. It's actually a big topic on paper 1. And we would not have spent a lot of time doing sets if I would not have been seeing a lot of sets questions on the paper 2. So I would not have done it in class in a formal way. I would have proper. So I want to take a moment today to look at sets, some of the main things we need to know about sets. A few questions students been asked me about some of the set stuff. So then we can address those today. But before I start, I'm going to take a quick look at the syllabus and show you. So all these things we're going to be doing, number theory and so on. This is a 70 page document. Right? This has like 71 pages in it. And then now this is basically a bank of questions of the 2024. So we'll go to the questions on this paper. We're going to also pull up at the January 2026, the 2025, 2024, and do those questions and those papers as well. Just to ensure that we have the full coverage of the most recent exam questions. Right? So you see, this is 71 pages of questions. We're not doing all of them today. We're doing them over 4 days, along with the most recent papers. 2026, January, 2 papers in 2025, and 2 papers in 2024. That's 5 additional papers in addition to this that you're looking at the screen. That should give us some real good, solid coverage for the multiple choice. The objective is only one objective you have for the multiple choice exam. One objective, and it's to get 60 out of 60 on a multiple choice paper. That we prepare hard for it. If you fall below the 60, we don't want to go below 58 out of 60. All right? And it cannot be that we are exposed to all this material or don't use it. We don't make maximum use of it. All right? So all these papers that we are fortunate to have, we have to maximize use of them. All right? So they come and they set back the same questions, we have to know how to do it. If they change the questions and give you new questions, we still have to know how to do it. Why? Because even if they make changes, they are going to be similar to these. And one of the primary objectives of today is to show you some of the ways that CSEC can make changes to a question, and you might not even realize it and think it's a previous question and mark the wrong answer, thinking it is a question that you are familiar with. All right? So we're going to do that over the next 4 days, starting today. All right? So basically 16 hours or more of work, but I've divided it over 4 days so we can do it in an efficient way. So 4 hours today, 4 hours tomorrow, 4 hours Monday, 4 hours Tuesday. Might not need all 4 hours on the days. I want to focus on 2 topics today, which is the sets and the consumer arithmetic. They're like 2 of the big topics on the paper. So if you look on the screen here, you're seeing the syllabus. So this is the paper 2 syllabus. We know that already. Over here is the paper 1 syllabus. Over here. This is the paper 1 syllabus. And you can see the topics. You can see sets. There are 6 sets questions on the paper. That's 6 out of 60. That's 10% of the paper is sets. 10% of the paper is sets. That's a lot. All right? And there's the consumer arithmetic. That's 8, even more. 8 out of 60 questions is consumer arithmetic. You have to solidify those 2. All right? So I'm doing those 2 today. You're going to come back and do the rest. Measurements again is another 8. relations, function, and graph, geometry and trigonometry, and another 8. But sets for a topic that we don't much of for paper 2 is 10% of this paper. All right. So that is what it is, guys. So these are the number of questions that make up the 60 questions for each topic. And they come in groups. So all the sets questions tend to come together. All the consumer arithmetic questions come together. All algebra comes together. All the statistics come together. Right? That's how they set them on the paper. The group them. Right? All right. So that's how we're going on to sets today, guys. But I'm not going to jump into the questions yet. I want to give us a little bit of background work, a little background talk, a little bit about set. All right. So let me scroll down to the bottom of this page. And we can just off the top of my head, some of the important things I can remember to tell you about sets. The rest of it will come out in the questions. All right. So I'm going to introduce the topic using the two subsets at the center. That's what we encounter most of the time. So a set is represented, can be represented in a Venn diagram. It's a rectangle representing what we call a universal set, and the symbol for the universal set is U. The universal set will have all the values in there, and they will describe that set for you and tell you what that set represents. So it might be the number of students who do physics from 3 different schools or from 2 different schools, a number of students who do physics versus who do biology, number of visitors to a country, all kind of stuff. Can be of anything. And you're putting them in groups that within that universal set that we call subsets. Can be a list of prime numbers, list of even numbers, list of prime numbers less than 100, anything that can describe. And the subsets are usually represented as with circles. Those circles can intersect each other like this. Or it can be that they don't intersect each other and instead be like that. Disjoint sets. So we're going to work with the ones that intersect each other to begin with, and then we talk about the other type going forward. And what they do, this might be, for example, set A representing the set of something, and this is set B, something else. Now, when they give you a set, they can present information in a number of ways. They can present the information in the set by telling you, by showing you the actual values in the set. So, for example, the set might have the letters P, Q, R, S. You might have T and U inside there, so, and you might have T, U, V, W, X. I might have Y and Z out here. That's me listing the elements of this universal set. This basically could be described as the set of letters from P to Z in the alphabet. P, Q, R, S, T, U, V, W, X, Y, Z. That's a combination of them. All right? They can also give it a set where they give the number of values in each set. Instead of showing you the actual values, they can instead show you the number of values. So instead of giving you the actual element in this set, they could have just written 4 in there. Meaning there are 4 values in that set. They could have given you 2 inside here, meaning that there are 2 elements or 2 members in that set. They could have just written 3 inside here, meaning there are 3 values in that set. And they could have placed that 2 outside here, meaning that there are 2 values outside here. So they can give you a set where you are now showing number of values. All right? They can also give you a set where they give you the percentage of the subset. They can give you the set in percentages. So again, we'll do another one down here and show you. Just as an example. So that this is the one where they give the actual values, where they show the values. It's an example where they're showing you the number of values in each set, each subset, and then now they can also give you, for example, where they give you percentages. So I'm not going to put the actual percentage that these represent. Important thing when they give you in percentages is that you know that the total must be 100%. Right? And if they properly is set now and they say, okay, you have 40% in here, and let's say they have 10% in here, and let's say they have 30% in here, or 20% in here, what's that we got? 70? Then you know you must have 30 outside here, as everything must add up to 100. So this might be 40%, 10%, 20%, and that's 70 so far. So you must have 30% out here. Everything must add up to 100. I don't need to put on the percentage. But I know that everything must add up to 100 because this now is showing the percentage of something. The percentage of something. And maybe the percentage of a population in a country. A are the ones who vote for PNP and B are the ones who vote for JLP. Or A are the ones who support PNP. B are the ones who support JLP all the time. The ones in here, 10 might be the ones who not so sure they support PNP and or JLP equally. And these are the ones out here who don't support none of them. By the percentage. They can also give the set with the probability values. Probability. So this is no percentage. We're going to give it as percentage. And they can also give a set where they're now showing the probability. So as an example here, when they give a set in probability of something happening, you know that the total probability must be 1. So here's percentage. Let's write them out. When they give set showing percentage, the one is probability of something happening. Right? This one will they show the number of members. They're showing number of members. Number of members. This one showing. And this one showing the actual elements or the actual members, showing members. This one showing members. The members are the elements of the set. You're showing what they can show. Now, when I give it its probability, the important thing is that the total must be 1. So if, for example, we have, let's use the same values up here. Let's say we have a probability of 0.4 that somebody supports A only. This is 0.1 inside here. This is 0.2. This add up to 0.7 right now. But the total must be 1. You automatically know that outside here must be 0.3. Probability of something happening is 0.3. So those are 4 of the main ways they can present you for information to be used in a set. One way to show the actual members, one way to show the number of members, one way to show the percentage of the members, and the percentage of whatever, and one way to show the probability of something. All right, let's look at some of the set notations now, some set diagrams and some of the set notations. I'm going to use the same diagram here. All right, and let me take all these elements and let's use some set notations. All right, so inside here it's set A. So if I shade everywhere inside here, that is just set A. So I've given you now the diagram for set A. That's just set A. Just A. If I take the same diagram and paste, let me copy this, paste it here. It's making you understand everything. Because if you get that shaded, then that is set A. If that is A, then we have a thing we call A complement. The complement of A now will be everything outside of A. So you're basically like a shading everywhere outside of the A. like this. So we're showing everything outside of the A is shaded now. All right, everything outside of the A is shaded. So we have shaded now a complement. A complement. Complement usually means not A. Right? So up here is A, set A. So this is not A. So this A complement means not A. Means everything outside of A. The complement means not outside of that. Right? Everything outside of A. So I've shaded everything outside of A. All right. Then now we can have A only. Show you A only now. Bring everything today. I show you A only now. People asking me, I just want to make sure if you know it already, good. If you know these things already, that's fine. All right. So in this example here, A would be all these values. And A complement would be these values. A complement. So if you're looking for A only, show you A only now, how that is represented. Very important. So A only is if I want just here, not including the part of the B. That is now A only. How is that represented? It's set notation. Right there alone. Got it good. So this part inside of A is not shaded because B is inside here. How is that represented? That is A and. Now this is the symbol for and in sets. This symbol right here. So it's A and A intersect. This could Mr. Shaw. A intersect. B complement. That's what you're right. A only. A only. Remember this A up here that we did included some of B. There was some B inside it. There's not A only that. So know the difference. So when shade all of E, that is A. If you shade A and it leave out the part that has B in it, that is A only. This is how you represent A only. But understand that. If I shade it over here alone, then that part would be B only. So this part, B only would mean B intersect A complement. But understand that. The verb. But good. Making sure. Taking my time with this in guy because I know we didn't do this topic. All right. Then we have inside here now. That is the intersection of A and B. All right. So if I copy this down, I paste it here. And I'm now only shading inside this place. That is the intersection. That is A and B. As I said, the symbol for and. That's A intersect B. That's where A and B occur together. Elements that are in A and also in A and B. So this is A and B. A intersect B. A intersect B. Okay, the same diagram again. Not leaving out anything in it. No, I'm sorry, I'm going to go through it still. Because I don't know if I don't know it for sure. All right, I test it up on it. So let's go. If I take this and I now shade everything in here, A and then add in the B to it. Everything there. And that is A and B together combined. That means A and A or B or both. That's what this means. So it's a union of A and B, this one now. A and B combined. So this means A union B, which really means A or B. You can take either or both. So union means A or B, meaning you include everything. But we don't normally say the or both, but the or both is also included. Because inside here now we the both. So this is A or B or both. Right? This is what we call the inclusive or, meaning it includes the both. Inclusive or includes the both. There is an or that means that is an exclusive or. So for example, the boys in the room or is not in the room. It can't be the two of them at the same time, don't it? Is that I'm in the room or I'm not in the room. So that's an exclusive or, is one or the other, for sure. But if you say the boys, if you say the boys outside or drinking water, it can be that outside, one possibility. It can be that drinking water, when you can be outside drinking water. So that is what we call now the inclusive or, because it can be doing both of them, outside and drinking the water. You understand? Good. So this is dark. This is the inclusive or, one that you can have the both. Then now, if you shade outside of those two areas, so let's paste again. I'm showing you all of them, guys. Showing you all of them. You can go back and watch this video. Go back through and think, I don't know what's coming on the exam paper. You need to understand all of them. All right, I might come up with some more. If I go now and shade outside here, around it, leave inside your thing, then I'm working on the complement now. This is outside of the A and the B. So anything outside here now will be complement of A union B. So this should be now A union B complement, which is not the union of A and B. That's what this should mean now. Everything outside of the A and the B complement. It's a complement of A union B. That's what that one would be. All right. So I think I would have covered all the possibilities here right now. All right. And they can combine these things. All right. So that is subset notations and so on. Oh, one more thing now. Some of the symbols. So give you a symbol right here now. So this means is a member of. This one in purple. Let me just introduce this. This means is a member of. That's what it means. So for example, we can say these values are members of set A. So you write this way. P, Q, R, and S, T, and U, all of them, or some of them, or even one of them or two of them. These two values are members of set A. Something like that. So that's how this could be used. Are members of set A. If you cross it now, it means not a member of. So you could write now, for example, let me shift this up. Just giving you, introducing some of the symbols now. So we understand what they mean. So if I cross it now, I can say the same P and Q. Same P and Q are not members of set B, because they are not in set B. The P and the Q, they are in A, but they are not in B. So when you say not a member of, you can cross that one. It's a member of. All right? It's a member of. So this is always referring to elements that are in a set or not in a set. This symbol are referring to members. Then you also have the symbol for subset. Give you an example now with subset. All right? That's one example. Subset now, which we can go like this. And that's when now you have a set within another set, right? So for example, if I put this in a larger set, this. And this is the B now. So let's go over Mr. Shaw. This inside here is B, outside here is A, same way. Then B is inside of A. So B is a subset of A. Or that is written like this. B is a subset of A. So that's a symbol of a subset. B is a subset of A. B is a subset of A. Right? Can also be read the other way, like this. A, and put the symbol this way. B is the same way this way. B is a subset of A. Or if you read it from left to right, it says A contains B. So this one now would mean A contains B. But I never give the second one that I'm writing, but I'm just introducing this thing. This one will read A contains B. Same as read it this way. B is a subset of A. So A contains B. All right? That's for that one. So I'm giving you those two symbols. And then again, if you cross it, it means not a subset, right? So you put a line across it, not a subset. All right. So I've spoken about that. All right. So I want to introduce to you now number of elements in a set. Well, let me tell you the set equation first. That everybody must know. All right, for two finite sets. Let me give you. Let me show you this equation now. And it also extends to a probability equation for two finite sets. Let's say I have two finite sets A and B like that. Right? Set formula goes like this. Remember it. It's going to pop up on. You might see two or three questions on the exam paper. Well, it's 6 questions now, but at least one of them you're going to use the set equation. Right? So it's called the set equation. Is this. The number of elements in A. I want to put NA right. It means the number of elements in A. So I'm going to go back up at the top again. Introduce that again. So up here, this example, if I write NA, means how many values are in set A. That's what that means. So when I put the N in front of it, it means how many values are in set A. What is that? 6, right? 6 values in set A. So that equals 6. If I write the number of values in B, that'll be this, 5 of them, right? 5. If I write the number of values in A intersect B, to be these two values in here. So 2 values in intersection. 2 values. So this number means when you want the number of values, right? So come back down now to the set thing. So the N in front, it means number of elements, number of members. So coming back to the set equation, it goes like this. Number of values in A, number of elements in A, plus number of elements in B will always be equal to the number of elements in the intersection A intersect B, and let's put it in the union, A intersect B. A union B, number of elements in A union B plus the number of elements in the intersection A intersect B. Whatever them two add up to, them two must add up to the same thing at all times. Number of elements in A plus the number of elements in B must always be equal to the number of elements in the union plus the number of elements in the intersection. Right? And then you can take this, for example. So any three you know, you can find the other one. So if you know them three here, I want to find this, we just subtract this over here. So If we know them three here, I'm going to find this. I'm going to subtract this over here, so. All right, now why is this so? Why is this the case? Let me show you why this is the case. Now, let me show you why this is the case. So the number in the union, let's start with the proof right from the union. The union means everything inside this, right? In the A and the B, right? So let's start with that proof. So the number in A, let's use color code. Purple plus the number in B would be equal to, let's sketch out the A now. Let's shade out the A. So the A would be everything inside here, so. That's the number in A. And I just did up the top, right? But I get that? That's the number in A, right? And then I'm adding the number in B. So the number in B, I'm going to cross at it like this. In purple. So number in B would be this. I see that? So start out with the number in A and the number in B. So it looks like the union right now, don't it? Don't it? Looks like the union. So it looks like the union. So it looks like the union. I'm sure I do it that way. Let me do it that way. Let me do it that way. Let me do it that way. So right now, we're starting out with the union. So let's say the number in the union. The number in the union. A union B. Looks like that, right? Looks like the number in A plus the number in B to start. What have we done? If you look inside here, in the middle, in the intersection, you notice that I have the red in there and I have the purple in there, don't it? See that? So it means that if I add the A and the B, I'm adding the intersection 2 times. I'm adding the intersection when I add the red, and I'm also including it when I do the purple. But I cannot repeat the intersection. So what we have to do now, we have to go subtract the intersection because I added the intersection twice. So for this equation to be true, for this to be true, I have to now go and subtract the intersection 1 time. Because the number in A, you add the intersection. And the number in B, you add the intersection a 2nd time. So if we're going to actually get the true union, we're going to have to subtract the intersection 1 time. So we're going to subtract the number in the intersection 1 time. See that? For it to be true. Right? Because I'm going to do the number in A plus the number in B. I'm adding intersection twice. Cannot add it twice. I have to take it out 1 time. So we subtract the intersection. And then you notice if I take this now and bring it back over this side, you see that I get back the original equation. So it becomes the number in the union. And then this comes over, becomes a plus the number in the intersection is now equal to these two. Number in A plus the number in B, which essentially is the same equation right here. So you just have to kind of turn it around. Turn it around. That's his all. So if you notice, this side is this side. Sum of the intersection and the union. This side. This side. Sum of A and B. All right? So this is very important, guys, to know. The sum of the A and the B, the number in the A plus the number in the B, equal the number in the intersection of U and number in the union plus the number in the intersection. We're going to see question we're going to apply that. Right? This thing must be applied somewhere. These two things must be applied in some questions. All right. The next thing I want to talk about is I want to talk about equivalent sets. 2 sets are equivalent if they have the same number of values. Simple as that. So if we have a set P, equivalent sets. cover all the things that you need to know. So anything I don't touch on here, so you want to see them in the questions. Have the same number of values members. So for example, if set A is 1, 2, 3, 4, and set B is P, Q, R, S, that means because the number in set A is equal to the number in set B. What is that? 4. It means that A is equivalent, that's a symbol for equivalent, to B. A is equivalent to B. So the question asks if two sets are equivalent, you're looking for the number of values in them. When the sets are equivalent, they have the same number of values. But get that. Equivalent sets have the same number of values. They have the same values, have the same number of values to be equivalent. Right? All right. Next thing I want to talk about is the number of subsets in a set. Number of subsets. Number of subsets. These are some of the main things CSEC asks you for. The number of subsets in a set is equal to 2 to the power n, where n is the number of values. 2 to the power n, where the n is the number of values, or the number of members. N equals number of members or values in the set. All right. So for example, number of subsets. If I give you a set A, and set A has the values, let's use P, Q, and R. P, Q, and R. P, Q, and R. And I'm saying that based on that, the number of values in this is 3. So therefore, the number of subsets will be equal to 2 to the n. 2 to the n, the n is 3. So it'll be 2 cubed. And 2 cubed is 8. So with this set, I'm saying that set has 8 subsets. Suppose to list the subsets. What will be the subsets? So the subsets would be what? Let's list them. We're supposed to get 8 of them, right? So let's list them. Subsets of A. What will be the first subset? What do we put as the first subset? Subset containing just one value each, right? So you have a set with P, you have a set with Q, and you have a set with R. That's a single value subset. You can have subset with 2 values. So you can have a set P and Q. You have a set the P and the R. You have a set the Q and the R. That's 6 subsets so far, right? I'll make up the next 2. What do you think? I'll get the next 2 subsets. It's 8 of them I'm supposed to have. What will be the other 2 subsets? What is set? What I want to tell the other 2 subsets would be, I've identified 6 so far. What's the other 2 subsets? The other 2 subsets are the 2 people always forget about that. So the first other subset is actually the empty set, or what we call a null set. So the empty set is a subset of every set. And the other subset is the set itself. So the full set is also a subset. So the other subset is the full set itself. P, Q, R. That's how we make up the 8 subsets. So it's 1 set with no value, 3 sets with 1 value each, three sets with two values each. And then one set, the full set itself, is also a subset. And there's a name for these things just in case I come on the exam. These six up here is what everybody will identify. They are what we call the proper subsets. And these two down here are therefore the improper subsets. So if you ever ask you see the word proper subset and improper subset, that's what I'm talking about. And the symbol for this null set, another symbol for that null set is this. Another symbol for the null set is what we call the null set, or the empty set. This is the null set or the empty set. And the null empty set is a subset of every set. The null empty set is a subset of every set. This is a null set or the empty set. Null set and the empty set is a subset of every set. So if you say this, that's an empty set. If you say this, that's an empty set. That's a symbol for empty set. All right. I can't think of anything else off the top of my head that we need to talk about for sets. Let's see some of it will come up with the question. Oh, finite or infinite set. A finite set is a set with a set number of values that terminates. An infinite set, it don't have no set number of values. Go on and on and on. So for example, a question I remember is like, let's say, the multiples of 5 is an infinite set. So multiples of 5 go on and on and on and on forever. But let's say the multiples of 5 with 2 digits, then that's a finite set. So we're talking about the numbers between 10 and less than 100, don't you? Those are the multiples of 5 with 2 digits. That would be 10, 15, 20, 25, 30, 35, for all up to 95. But I can't include 100. I was talking about 2 digits. That would have a fixed number of values. That would be a finite set. So you have infinite set, no ending value. Go on and on forever. Finite set and a set number of values. Those are two other things that I remember off the top of my head now. All right. So if I make a note down here, finite set has a set number of values. An infinite set has an infinite number of values. It's in the word, don't it? Finite number of values. An infinite number. Infinite means never ending. All right. I think we're going to go to the question now. I can't remember anything else off the top of my head. Anything else to do will come up in the questions. I can't think of anything else. This I'm not giving you this all the top of my head right now. And I can't remember anything else to give you. All right. I think that's that. Let's get to the question. I'm going to do the sets part of the thing, right? Let's get to it. Oh, it's on the same topic. Let's get to it up here. Sets. Oh. Let me talk about one more thing in sets. Because I set like to use those the real number system. So I'm going to talk about that a little bit. The real number system a little bit. Real number system. And mainly I'm going to talk about the symbols and the real number system. So R is a symbol for real numbers. I mean any real number. Any real number. Whether a fraction, positive number, negative number, surge number, any real number is represented by the letter R. Any or all real numbers. Let me put all real numbers. That's what this means. Any or all. Any number we can come in a calculator. The decimal, a fraction, any number. It includes negative numbers like -3, -4/3, negative fraction, positive number. It includes 0. It includes numbers like surge numbers like √2. That's called an irrational number. Include rational number, even normal number like 4. Any number, any size number, 500, it no matter. Any number, even the number pi that we used to, is a real number. Right? Anything we can come out to a qualifying character is a real number. Right? Then we have inside the real numbers, we have a rational and irrational number. So this is what we call now Q is the symbol for rational numbers. Now, a rational number is a number that can be expressed as a fraction with a whole number numerator and denominator. That's what we call a rational number. Any number that can be expressed as a fraction. So can be expressed as a fraction with a whole with a integer numerator and denominator. It's a rational number. Can be expressed. Can be expressed as a fraction. That's why I say rational ratio. As a fraction with integer numerator and denominator. So, you know that when you have a thing there. So as a decimal, see these rational numbers as a decimal, something to note. As a decimal, when expressed as a decimal, when expressed as a decimal, the values, when expressed as a decimal, it terminates. It terminates. That's what I mean by terminates. Or the values repeat. Or the values, the values repeat or recur. The values repeat or recur. Recurring decimal recur. What do I mean by that? So for example, 0.75 is the same as 2/4. It terminates. That decimal that terminates. 0.35 is 0. Thing, right? If you see one like this, 0.2929292929 forever and ever, amen. That's a rational number as well. Because the values are repeating 292929. It can be one value repeating like 0.33333. Everybody know that is 1/3. Everybody know say 0.666666. That is 2/3. So you can have 1 digit repeat, you can have 2 digits repeating, you can have 3 digits repeating, you can have 4 digits repeating. Once there's a repeating of the pattern in the values, it also can be expressed as a fraction with whole number, numerator, and denominator. I can actually work out what this one is as a fraction. And you could get on the calculator. Got to be 29. There you go. 0.29. Show 0.29 equals 0.29 times 1 and times 100 times 100. So 29 would be 0.29 times 100. Right? And if I subtract them, I get 99. So I must subtract them. I don't remember all of this thing, but it looks like something over 99. Let's see if it's 1 over 90. I don't know quite. But it's not that. Let me see. Let me get to this. Let me get to that to you from my device. All right, so we'll do this again. All right, so over to this again. There's a way to prove that this number is a rational number. There's a way to prove that this number can be expressed as a fraction. Something like this. It is 1 times 0.2929 repeated is equal to 0.2929. Right? And then you multiply this by 100. Multiply this by 100. You get 100 times 0.2929 repeated to be equal to, okay, I remember, 29.2929 repeated. Right, and I subtract it. Good. So it will be 99 times 0.2929. 0.2929 repeated equal, this becomes 29. But this minus this becomes 29. It's 29. So it becomes 29 out of 99. 29 over 99 equals 0.2929. All right, so 29 over 99. Let's look at it. 29 over 99. 29 over 99. See there? 0.29292929 forever. So you see that 0.29292929 can be expressed as a fraction. Right? Can be expressed as a fraction. Bring up the other calculator. Bring up the other calculator for you. And show you. Let's use this one. See it here? So I put 29 over 99. See? That line over the top here means that the 29 is repeated. On the calculator, 29 with the line on top means that the 29 is repeating. That's what it means. Right, the 29 is repeating. When you look at this number right here, the line over the 29 means that the 29 is repeating. All right. So I don't want to digress too much from this because I really want to be doing the sales. I digress. Let me come back to what we're doing. So that's what we call rational numbers. All right. Delete. All right. And then now we have irrational numbers. And irrational number is a number that is not rational. That is Q prime. That is an irrational number. And those are not rational, means that they cannot be expressed as a fraction and cannot be expressed. If you express it as a decimal, they don't terminate and the values don't repeat. They do the opposite of what the rational numbers do. All right? That's the irrational number. And examples of those are like root 2, root 3, root 5, and believe it or not, pi. Pi is an irrational number. When they say pi is 22 over 7, that is just an estimation of the real value of pi. Not the true value of pi. I can show on the calculator quick. So pi is actually an irrational number. 22 over 7 is just an estimate. Look at it carefully. If I put in pi in the calculator, look at it again. Look at those digits. I get 3.1, 3.141,592. Notice the values don't end. See the arrow at the end? You see the arrow at the end of this thing? If you look at this line, right down to the end of the line over there, you see the arrow. See this arrow down here? This arrow right here, so. Right? It means that they go on and on forever. And note the values are not repeating. Right? So pi is an irrational number, never terminates. It go on and on forever. Over number decimal piece the calculator can do, it will continue. But if I show you 22/7, I'm going to say a different number for 22/7. Look, if I show you 22/7, so I get a different number, 3.142857, and these values repeat. That's why I lined it over there. So you see two different values that. So you see that in reality, pi is not 22/7. 22/7 is just the closest estimate to it. But this approximates 3.142, and then say 22/7 is the closest rational estimate to it. You get me? Good. So pi is not a rational number in reality. It's an irrational number. All right. So make a note of that. All right. So the other ones I want to talk about now are, so I talk about real numbers and things. So you have what we call natural numbers, N. Natural numbers are your counting numbers. Natural numbers. N is for natural numbers or counting numbers. So if you say N in a question, it means natural number. You have to know these things in a guide. Natural numbers. And your natural numbers are the numbers that you count with naturally. If you tell a baby to count, they're going to start counting from 1. They're going to say 1, 2, 3, 4. So that's the numbers 1, 2, 3, 4, and so on. Those are your natural numbers. Numbers that you count with naturally. Then W. W is for your whole numbers. So if you see the letter W in a set question, it's talking about whole numbers. Whole numbers are formed when you add 0 to your natural numbers. So it becomes 0, 1, 2, 3, 4, and so on, all the way up. Those are your whole numbers. Then you have what we call integers. You're going to see a lot of integers. C is for your integers. And integers are your positive and negative whole numbers. Like, for example, say, come like so. Like -3, -2, -1, 0, 1, 2, 3. 3 because that means that they go on. So go on, go down to negative infinity down the sun and go up to positive infinity up the sun. So integers are your positive and negative whole numbers. You have to get familiar with these symbols. You put them in a question, you have to know. C is for integers. W is for whole numbers. N is for natural numbers. I don't might give you these two, but just in case you know them. 2 is your rational numbers. Right? And R is for your real numbers. I think these are the ones that you most likely to see in questions. N, W, and Z. Right? Because we're really working in real numbers right through. All of them don't are real numbers. All of them are real numbers. So the real number is on top. Real number include all of them. Get me? Real number include all of them. But I think these are the ones only you're gonna see this. All right, ready for your question now. We're going about an hour when I touch a question it. Which is 4 hours draft, so no problem. So after we finish the set, we take a short break and then we'll come on the consumer arithmetic. All right? Question time, guys. Question time. I know you want to see questions. Let's go. I know that's what you're here for. To see questions done. I know. You just want to do questions. Let's go. All right. So what I want to do is run through these questions. All right. These sets questions. So just in case anybody have any problem with this, we can sort of clear up some of the things now. And I also want to look at some of the set questions from 2026 January over down to 2024. And this includes questions of the 2024. So we'll go through this first and so how much more we have. Let's go. Let's do them quickly. I also want to look at the similarities and differences of the questions. So these two questions are similar, but there's a slight difference. And if you go in the exam trying to swap questions, you might mark the wrong answer, thinking that it's the same question. Let's look at this first one. This first one says, which of the following statements describe the set of integers? See, integers, that's what the Z is here, so the Z is for integers, right? Greater than 0.3. Greater, that means it's -3, sorry. That means a -3 is not included, but less than 6, means that 6 is not included. So we want greater than -3, but less than 6. Which of these symbols represent that? So you mean that you can't put the equal upon the negative 3. You can't put equal upon the 6. So you're between negative 3 and 6, not including negative 3 and not including the 6, right? You cannot put equal on them. So the answer is the last one down here. So that's the last, that's the answer. But I agree with that. It means that the x is greater. See there, the x is greater than negative 3. And the x is also less than 6. Now this one can be spun around. Read like this. X is greater than negative 3. And then I put these two together. Like that. See it? That is it. See that? So I'm saying, this is saying x is greater than negative 6, which is same as negative 3, which is same as negative 3 is less than x. This one is what they said, x is less than 6. But when you write in these things, you always put the smallest value upon the left, the largest value upon the right. And it's one continuous region. So this now can join with this. Oh, I rotate it. This now can join with this. And then that is the answer. All right? Look at this one. It's got the same question almost, but this one now says from negative 3 to 6. Once you say from negative 3 to 6, it means that you're now including the negative 3 and the 6. You get me? You're now including negative 3 and the 6. So in that one now, the equal has to be there. Notice the equal is not on this one. So you might see the question and think it's the same question. I remember the negative 3 and the 6 and so on. Reads like the same question. But the answer for this one is actually this. You have to equal the negative, you have to include negative 3 and the 6. So the answer for this one is actually this one. A lot of people going to look at the swatting question. They're going to mark this one again. We should be wrong. That is why we must not get into the habit of swatting the questions, guys. You have to read the questions carefully and look at the difference. See, that's a big difference. Second one says from negative 3 to 6, meaning you're including the negative 3 and you're including the 6. How do you include this? Include those values? By putting the equal. By putting the equal and the inequality sign. See there? The equal and the inequality sign. That is the difference. This one did not include it. So I choose it over here. And it only said greater than and less than. Those don't include the values. But I said the difference. So right here, the answer will be this one. Nope, Mr. Shaw, nope. That is it. Next question. Which of the following set defines this? So you see, you have to know that this means integer, right? And you're going from negative 2, I notice the equal is on it. And you're going up to 4, I get the equal is on it. So including the negative 2 and including the 4 this time. So the answer for this one is down here. See that? If the question change, and instead of putting this, they put negative 2 less than x, less than 4. Then this will be the answer right there. So that one, this one, and I say x is integer again. They put the z again. So that will be the answer. They put change. If they change this inequality to this, that one gonna be the answer, you know. C. They put the same thing. They put the same thing here, so. Right? Well, that one have to include the 4. They can put that. But watch if they do this now. Watch if they do this. And they put W. That could be the answer. The W don't include negative numbers. Whole numbers. W mean whole numbers. They start from 0. See that? And for they could put the same thing for this one. And put negative 2 less than x. Less than or equal to 4, but this time they put n. Natural numbers. Natural numbers start come from 1. So this would be it for 1. For that one, for this, they give you this. Understand the difference? Very good? All right. So I'm saying that these are some of the simple ways CSEC can change a question, and the answer is different. Minute little changes. Minute little changes. Right? And the answer will be different. All right, next one down. Oh, it's a question over here. No, not ready for that. This one. This one says, the Venn diagram shows two intersecting sets P and Q in the Venn diagram. The number in P is 5, number in Q is 9, number in the union is 10. This one is easy enough. Remember, we just give the formula where we say some of these two must equal the sum of this one and P and the P intersect. P intersect Q. This is union, P intersect Q. That's what we said. So them two here, when you add them, must equal them two here, we add them. See that? So the sum of these two must equal the sum of these two. So what you know? If them two you add up to 19. No, not 19, that's 14. 9 and 5 are 14. And this is already 10. This one must be what? 4. I would say they must equal the same thing. See, that's what we said earlier. Let me write out to you something. We said the number in P plus the number in Q must equal the number in the intersection or the union plus the number in intersection. Now, if these two add up to 14, that's 5 plus 9, which is 14. It's add up to 14. Oh, yes, I must add up to 14 too. And if this part already is 10, what is it going to be? 4. It's going to be 4. It's an easy question. Let's call that one X. If I add up to 14 too, you put 4, 14. See that? So it's going to be 4. It's going to be 10 plus 4. So the answer is 4. But understand that? You can't fast. If we get these answers speaking, I'm going to try to examine now. Go about the bill. Right? It's an easy formula for remember. Number in those must equal to those. So they must add up to the same. All right, let's look over here. So let's look at this question. This question gives us these three sets. P, Q, and R, and ask us for this. This means the intersection of the three of them. P intersect Q intersect S. So what value is common to all three of them? P, Q, and S. So look at the 2 first, is in all three of them. Another value? Nope. So the answer is just 2 alone, don't it? And the answer is 8. Only 2 alone is in all three, don't it? Look at this now. They give the same P, Q, and R, same 3 sets. But now look at what they're asking. Let's zoom up on it. So they're asking here now, they put a bracket around this. So I've actually changed the question by simply putting a bracket around this. This is Q union S P intersect. That's what I have now given. So a lot of people going to think it's the same question. And remember the P, Q, and the R, and they kind of the brain remember that. And then the exam, they're trying to go off memory. And I think it's the same question. I remember so the answer for this are 2. I come from 4 past paper and answer 2 for all of them. And I think that is the same question. But this actually might be different if we work it out. So you know you want the intersection of the union of Q and S. You have to work out what the union of Q and S is first. Right? So we're going to work out the union of Q and S up here. So the Q union S will be equal to all the values in Q and S combined. But remember, I don't put repeat values. You don't repeat any value. Right? So you have 2 in there. You have 3 in there in the union. You have 4 in the union. You have 5 in the union. And you have 6 in the union. That's union right now. And what is P? P is the value that they gave us that set that they gave us initially, which is just these 2, 3, 5, 7. 2, 3, 5, 7. You know what the intersection between those two sets that we have on the screen? Right. So you have 2 in both of them, 3 in both of them, 5 in both of them. So that says 2, 3, 5 right here. I say them have the same answer though. Same answer them have enough. See, them have the same answers. So if you try to go off memory, you might just think this is the answer up here, so which is wrong. Because you think it's the same question. They present the same answer, but by simple making this little change, it is no different. So you cannot depend on memory. Work it out. So the answer for this one is this. And look for CSEC to come and do the same question again, but present the same information and make a simple change to this again next time. Look out for it. So you have to know the word them. Cannot go off memory. King? Cannot go off memory. Let's look at this one now. So this one is asking us the same question, but this time they didn't shade inside here. The same one as what we did over here a while ago. Right? See, they present the same thing. The 5 and the 9 with the P and the Q. P is 5 and the Q is 9. You can see it? See there? This is 5, P is 5, Q is 9, the union is 10, and they're asking us for the intersection. What do we know? These two, again, add up to 14. These two also add up to 14. Add up to 14, this is going to equal 4. See it? And this is 10 already. Again? Again? So the same question. So this is 4 again. Over here, similar question. They give us the universal set is 25. They give us the number in A is 14. And they give us the number in B is 15. Number in the union is 23. Another one, the number in the intersection. Same thing again, guys. These two right now add up to 29, don't it? These two add up to 29. Using that same formula again. The sum in A plus sum in B. Number in A plus number in B must equal the number in the union plus the number in the intersection. So these two must also add up to 29. If this is already 23, it means that this has to be how much? This has to be 6. See that? The answer is 6. But I go to this and understand. If you don't understand, talk, you know. But good. Online, but okay too. Using that same equation that we said. Let me write it out one last time. The number in A plus the number in B must all be equal to the number in the union plus the number in the intersection. Whatever them two you add up to, them two must add up to the same thing. It is as simple as that. So them two you add up to 29. So them two you must also add up to 29. These two. This and this must add up to 29. This is already 23. You need 6 more to make it 29. But I go to that. So that's why this is 6. Let's continue. Down here says, this one refers to P is prime numbers, Q are odd numbers, R are even numbers. So which of the following is an empty set? If you notice, they have given us intersections and unions. Well, that's a union. Those first 3 are intersections. So they have the prime numbers, the odd numbers, and the even numbers. Which one of these is an empty set? Which of them is an empty set? An empty set is the one that when all of them are equal to 0. Is the P and R equal to 0, to nothing? Is P intersect R equal to nothing? These two. that equal to nothing. The intersection between P and R. P are your prime numbers, R are your even numbers. Is there any prime number that is also even up? Give 2. So this actually is 2. So this is not an empty set. This is 2. That can be the answer. In fact, 2 is the only even prime number, don't it? All right, next one. Q intersect R. Q intersect R. Is there any number that is odd and even? So this is the answer. This equal a null set. So this is the answer they're looking for. See that? That's a null set. What about P intersect Q? P intersect Q. Wholly, don't it? Every prime number is odd except 2, don't it? So this is about wholly. And then the union now is just a combination. So you can't use this as an answer, right? It can't be an empty set. Union can't be an empty set. So this is the answer right here. That's an empty set. Now, these are what we call disjoint set. If I were to shoot that, put a set diagram for this, it will what we call disjoint sets. Let me show you. I did mention disjoint set earlier. So if I put in the set for P, the set for Q, sorry, and the set for R, there will be 2 separate sets. Disjoint, there's no intersection. That we call disjoint sets. Another good example is I remember for disjoint set. Even an odd number come in disjoint set because there's no odd number that is also even. Another common example is when you toss a coin and get in a head or a tail. There's no combination of a head and tail. When you flip a coin, there's no way you can get a head and a tail at the same time. So either get in a head or get in a tail. Again, those will present disjoint sets. Get me? You cannot get a head and a tail same time when you flip a coin. It's going to land on one side. But those are some common examples of disjoint sets. I better go to that. Good, and that's why the intersection is empty, the empty set. All right, let's continue. This one gives us set A and gives us set B. And it says, which of the following statement is true? Which of the following statement is true? This one is saying B is a subset of A, don't it? Let's look if that is true. So you have B have 6 in it, have 9 in it, have 12 in it. So true, you can fit all of B inside of A, don't it? See that? So this statement is true. B is a subset of A. Again, B is a subset of A. But this means subset, right? So B is in fact a subset of A. So this one is true. B is a subset of A. You can fit all of A inside of B. All right. You don't talk about this joint set again. Nope. Because there's an intersection. This joint set are sets that are bring them. B is a complement of A, not A. B is a complement of A. No, because it's the first one is the answer. Next one, it says, if the universal set is 1, 2, 3, 4, 5, 6, and H is 3, 4, 6, what is H complement? What H complement mean again? Everything that is not inside of H, don't it? But is still in the universal set, right? So we have accounted for the 3 right here, 4 right here, and the 6 right here. So the values we have not yet accounted for are the 1, the 2, and the 5. 1, 2, 5 would be the complement. Agreed? The values that are in the universal set, but not in H. 1, 2, 5. But okay with that? Online, about good? Not hear anything from the online people on the quiet, so. Not so quiet. You should understand if you don't understand, talk. Let's continue. I'll finish this, take a break, and we'll go to consumer arithmetic, right? Over this side. This one says the elements of the set. See, you know, let's look at this. Let's rewrite this. Make that up right, right? Rewrite it in blue. So this is x is such that 6 is less than or equal to x, but less than 10. That's what that is saying. So they are integers. That's what that is, integers. This is the word integers, meaning z. Which are the it is? So this greater than includes the 6, don't it? But it does not include the 10. No, sir. So including the 6, but there's no equal on the 10, so not including the 10. It looks like B, right? This out of it, this out of it, but I include the 10. This one don't include the 6, that one out of it. So the answer is B. But can I give you that? All right. Now go to that, tell me some soon, you know. I think I do all of them by myself. Then I give us these two sets. M is PQR and N is PQ. Which of the following statement is true? Which of these is true? This one is saying M is a subset of N. This one says, is M a subset of N? Is M a subset of N? Is this one true? First one. No, it's more the other way around, don't it? So this one is not true. What about this one? M intersect N equals N. Is that true? The second one. Is that true? What is M intersect N right now? What is it equal to? It's equal to PQCMA. You there? Where the intersect will be P and QCMA, don't it? That's all? So this one equals PQ. If you notice, the PQ is also the N, not it? PQ is still the N, not it? Agreed? So it means that B is true. This is the true one. All right. Next one. This one down here. It said, which are the following that pair of disjoint set? Same question asked about power again. Disjoint set. What it said, disjoint set up here, we say sets that don't have no intersection like this. Disjoint sets. Sets who have no intersection. Which are the following that's disjoint set? It says E are even numbers and F are odd numbers. Are those disjoint sets? Yes, but there's no even number that is also odd. So the answer for this one is this. But understand that? What about that? This one can't be true. Because multiple of 2 and 3, for example, 6 is not a disjoint set. Eh? Whole numbers that are rational numbers. Every whole number is a rational number. Why? For example, whole number 4 can be written as 4 over 1, which is a rational number. See that? So every whole number is a rational number. I can be a rational number. And then multiple of 5 and multiple of 10 can be. 50, for example, would be in the intersection of multiple of 5. Okay. So the answer is A, even numbers, odd numbers. So basically, the same question up here, you're basically given a different way. This one up here that we did. Same question, I'm kind of given in another way. All right, don't listen now. So this one says, all students in a class play Scrabble or checkers or both. Now here, when they start to give you information in percentage, you have to know that the total must be 100, don't it? That's all? Total is 100%. So you have to account for 100%. And what you can do sometimes is draw a Venn diagram of what they're talking about. So you have information in front of you. You want to try that one after a minute and tell me when I get all students in a class play Scrabble or checkers or both. In that there's some intersection and they play both. 36% of us play Scrabble only, that's in the Scrabble only part. And 16% of the students play both Scrabble and checkers, that's in the intersection part. What percentage play checkers but not Scrabble? What percentage? That means checkers only. It says all of them play. So in other words, there's nobody unaccounted for. The key thing is that total must be 100%. So you can draw a Venn diagram to show the information and then you work it out. What the answer? Huh? 48? Anybody else? 48 and I say? So if I draw a Venn diagram to make sure I know that we're working up to 100%. 100% out. do my Venn diagram in percentages. So I have one set for Scrabbles, one set for checkers. Scrabbles, checkers. What them say? Them say 36 page Scrabbles only, 36 inside or so. Them say 16 play both, 16 inside or so. Remember, why outer side zero? Why the OTS be zero? Because I say all students, all the students. We're talking about all the students play Scrabble or checkers or both. So there's nobody who don't play them. So outer side zero. But understand that? But I go to that, outer side zero. So everything in this must add up to 100. So we need to find its value right here. So it's actually 48 to 2. So the x, the 36 plus the 16 plus the x equals 100. So the x equals 100 minus the sum of the 36 and the 16. 36 and 16 is 52, right? 100 minus 52, x equals 48. That is it. All right. Over this side. This question says, diagram referred to the Venn diagram shows two intersecting sets. So number of students, each set is indicated. So this one is showing the number of students now. All right. It says in the Venn diagram, you are the ones who play games. Other F is everybody. Universal set for people who play games. So H is those who play hockey. V are those who play volleyball. This question says, how many students play neither hockey nor volleyball nor both? How many students play neither? How many students play either? Wow. How many students play either hockey or volleyball or both? How much is it? Huh? Oh, but not both. Thank you very much. Not both. So you want either hockey or volleyball. Now the all usually mean that you added them. Right? We don't want both. So you're talking about these, don't you? 9. Those who play hockey, either hockey or volleyball, but they don't play both. They're talking about these two. That's 9. Right? That's 9. What about this? The same diagram and a different exam, and I ask these questions now. The number of students in each set as indicated, right? It says, how many students play exactly one game? How many students play exactly one game? Same Venn diagram. How many students play exactly one game? The same thing. They might play hockey only. They might play volleyball only. They might play both. They might not play none. So the same answer. One game. So one game. They might play hockey alone, volleyball alone. So the same answer 9. So you see, the same question, same answer, but asking something different. But the answer is the same. But I can appreciate that. All right. Next one. The two-digit positive integers that are divisible by 7 is an example of a improper set, an infinite set, an empty set, or a finite set. Which one? Finite. Because they put in the 2 digits. You only want the 2-digit ones. 2 digits. Multiples. Remember, if it's divisible by 7, it's a multiple of 7 as well, don't it? This means also multiple of 7. A number that is divisible by 7 is a multiple of 7. So we're talking about the 2-digit multiples of 7. So like starting from 14, right? And then 21, and then 28, and so on. That's all. And going up to that value that is a multiple of 7 before you get to 100. I think that's 98. Right? It's a large two-digit number. So that's a finite set, don't it? Finite set terminates. You only want the 2-digit ones. Got this one now over here now. This one says the set of positive integers that are divisible by 6. What's the answer for this one? Finite, empty, infinite, improper. What the answer for this one? Huh? Huh? Infinite. Because they never say 2 digits now. They must say positive integers now. They never say 2 digits. So that those multiples will go on and on and on and on forever. So all the multiples of 6 you want. So that's an infinite set now. All right. So far, so good, guys. So far, so good. Next one down here. This one says Venn diagram shows universal set and two sets T and C, which represent students who play tennis and those who play chess. How many students play both games? How many students play both games? How many students play both chess and tennis? Huh? Where are the students who play both games? Where are they? Once you're inside here, so you play tennis too, you know. If you're inside there, so you play chess, but you're inside of the tennis set as well. It just means that all the people who play chess, all the people who play chess also play tennis. That's what it means. Them two persons here who play chess, them also play tennis. You get me? So it's two sports them play. These are the two persons who play both games. They play chess, but they're also within the tennis subset. Or within the tennis set. Yeah. So the two of them. So this is two. What I go to that? And this question says, how many students play exactly one sport? So where are the students who play just one sport alone? Four of them. These only play tennis. See them here? They're playing only one sport. If you ask how many people play no sport, which one, what is it? Them two of that, don't it? Play no sport. Oh, one of plays that, three of them. So that says four persons play only one sport. That's all? So this one is four. So it might check by the same diagram and ask how many persons play neither tennis nor chess. Last, how many students play at least one sport? What will be the answer? So we say, how many students play at least one sport? What will be the answer? Said at least one sport. At least one means one or two. Eh? Six. There'll be all the people inside us so play at least one sport. Just like them and play one alone, and them two in us play two. So we give out the same diagram and say how many people play at least one sport. Not exactly one sport, no. At least one sport. And put it on us. So. If them say at least one sport, say that exactly, we're gonna say no, at least one sport or one game. Answer about that one will be the sixth standard or so. Them have said that. Write out the same thing them again. So if the answer choice is A, 2, B, 3, C, 4, D, 6. And the correct answer will be this one down as 6. The ask if how many people play at least one game. So exactly. They can make that change, you know. Simple as that. They change the word exactly to at least. And there's a different answer you want. Because at least means one or two. So the 6 people in us would one or 6 of them. All right, let's go. Up here now. So we refer to a Venn diagram which shows the number, the members of a sports club who play rugby or basketball. It says the number of members who play rugby but not basketball is what? What's the answer for this one? They play rugby but not basketball. That is 15 people in it for the one. No, sir? Rugby only. Answer is 15. All right. The one people who play basketball but not rugby, they to be 13. The one people who play both basketball and rugby to be 12. That's all? All right. Next one. This means the number of elements in set A is M. Then the number of subsets, see? Number of subsets is asking for the number of subsets. We did that earlier. Number of subsets, we studied the answer with number of subsets in A. Huh? You said 2M? There's no 2M there. That's 2 to the M. That's not 2M. 2M and 2 to the M are two different something. 2M means 2 times M. So for example, if the M was equal to 3, then 2M would be 6. But 2 to the M are 8. See it? There's 2 to the M you want. And my numbers, say 2 to the M then, mom. So remember, number of subsets is 2 to the N. That's all we need to remember. This time the N is equal to M. That's all. All right? So the answer is this one. All right. Next one. So see, same kind of question here. Q is ABC. How many subsets can be obtained from set Q? So in this example, the number would be equal to 3, don't it? So the number of subsets will be 2 cubed. The answer is this one, don't you? So number of subsets is 2 cubed. All right? So 2 to the N will be equal to 2 cubed. Next example. This is a positive integer is an example of an infinite set. Positive integers. Go on and on and on forever. So that's an infinite set again. Next one. You could do this question earlier. Can I put like a change on it? So remember now, some of these two, because some of these two must be the same. That's all. What is 2 add up to 29 again? These add up to 29. These must be 29 as well. So this is 6. What is this going to be? And same question, I must change, you know. This is 6, then this is going to be 23, don't it? And the two of them must add to 29. So this is 23, right? So far, so good, guys. Next question down. Same thing again. Let's say P and Q are two sets. And now they give us a union, they give us the intersection, they give us a number in P, and I want a number in Q. Same question. Look again. Same thing. These two must equal to these two. So those two add up too much. That's 19. These two must be 19 as well. So if this has 9, then this will be, to be 10, don't it? This has to be 10. So I'm just gonna get easy. That is it. So this has to be 10. All right. Them two add to 19. The union and intersection add to 19, and the number in P plus the number in Q must also add to 19. So if one of them are 9, other one will be 10. And they must add to 19. All right? Simple. All right, this one now. Same question again. This one says if X and Y are two finite sets, such that number in X is 9, number in intersection is 4, number in union is 5, is 15, what is Y? Same thing again, right? Don't it? So them two here add to 19. Right? So it's the same thing again. So X intersect Y plus X union Y are equal to number in X plus a number in Y. Right? So this is what? Oh, this is the intersection is 4, union is 15, number in X is 9. So this is about to be what now? So this is what? 19. So about to be 10 again, not it? Same thing, 10. The same question they're just trying to present it in a different way. Don't want to say the same thing again, guys. Same question. So them two are 19 right now. So this is about to be 19. You want to? You see, same question changing up the values. Two are 19, them two have to be 19 too. So therefore that value has to be 4. Don't it? 15 and 4 make 19. See that asks this a lot. Alright. This one. It said in the Venn diagram, the shaded region is what? The shaded region is what? P complement. Outside of P. So it's P complement. But I hear that? Good. P complement. Outside of P. Shaded region is everywhere outside of P. Next one down here. So look at that. In this Venn diagram, the unshaded region is what? The unshaded region is what? Huh? It is Q only. The unshaded region right here. Look over this side. It's unshaded region right now. It's Q only. Why you write Q only? Q intersect P complement. Meaning you're inside of Q and you're outside of P. So you write it. You're inside of Q, but you don't want a part here. So we take out the P. See it? We take in, not include the P. Right? So that is it. When is that? The last one. See it? It's our complement and right here. The last one is the answer. So far, so good. But good. Just trying to get easy. That's what we have. Two more pages I'm bringing the most recent exam question there. And I'll tell me the answer them. 2026, 2025s, and 2024. Let's finish this. I'll bring up those papers afterwards. Listen, which are the following set is equivalent to PQRS? Which one is equivalent to it? What do you know about equivalent sets? Equivalent sets have the same number of values. So in this set, n is equal to 4. This set, n is equal to 4. So that the sets that have the same number of values are the equivalent sets. Come on, we have to remember these things. What if you said doubtful a while ago? Right? Equivalent sets have the same number of values, even though the values different, are the same number of members. That's what you're looking for. This is the same Scrabble question that we just did. Let's see if we make any change. All students in a class play Scrabble or checkers are about 36 play Scrabble only, 48 play checkers only. So I'm kind of change that a little bit. It's a what percentage play both? It's a 16. So you say the rearrange information was the same question that we did up here, basically. And they are rearranged. You are so far up with it. Right here, so this is it. So can they copy this down? The same question I have basically rearranged the values. So in this case down here, I give us the 16 this time. I give us a 48 inside here. And they're asking us for the 16. I see that. So let's need to change this. 48 plus x. Subtract 48 over here instead. So 640 how much? 640 how much? 84? Yeah. So x equals 16. So the same question that I've rearranged the values, right? Same information. Down here says the Venn diagram, X represents the set of factors of 12, sorry. Y represents set of factors of 9. Shaded region represents set of all factors of 1. So what you want to do is list them out and see what that intersection is. That's what I would do in this question. But I don't try to guess it, right? So the intersection is what? What will be the intersection? X intersect Y. We do write down what X is first. X are the factors of 12. What are the factors of 12? Start from 1. 1, 2, 3, 4, 6, and 12 itself. Y. What is Y? Y represents the factors of 9. Factors of 9 are 1, 3, and 9 itself. Then we have the intersection. What's intersection? The intersection is going to be 1, 3, 1, 3 alone. So intersection here is 1, 3. And 1, 3 are the factors of 3, don't it? Factors of 3. That is it. What about that? But that, oh man, I'm going to next set for dinner. They like to set this question, guy, with the cats and dogs in multiple ways. Depending on which question I go, any one of these 4 can be the answer. Right? So, I remember one year, I did a session where I went through this question. And a student came on after I was going to the paper afterwards. And she said, "But sir, the last question answer was B, sir." So you a different question, the same information, same thing regarding against. Same information, and I'm sure that I said, depending on which exam you do it, they will modify the information and the answer will be different. But the same cats and dogs question, so you can't just go after the memory of the cats and dogs question and say, the answer for the cats and dogs question is this. Right? They can change the information about the cats and the dogs. And then the correct Venn diagram will be different based on information. And the best way to do this question, or do these questions, is a process of elimination. I like to tell students, correct answer is there on the paper. And a lot of the time when you work in the question, you want to look at the answers. So you read the question and look at the answers. Especially when you're doing a consumer oriented question, you're gonna see that that is very, very important. Because I feel like we have to work out everything. Especially with those consumer oriented questions, you don't have to work it out to the end. Sometimes you can see where the answer is going based on the value that you have. You get the marks for working out everything in you, get the marks for selecting the right answer that is there in front of you. All right? But anyway, we'll get to that stage, we'll deal with it. So this one says, the 30 students in Teacher May's class have either a dog or a cat or none of the two. So the person have a dog or a cat or they have none of the two. So when I say they have none of the two, that is telling me that there's no intersection. So my mind is telling me that this is answer to get going up, to start with. They have a dog or a cat. They're not saying on both. All right? I'm thinking this, but I'm not going to declare it. It says all students who have a dog also have a cat. You know what that means? Subset. So now I choose this again. This is it. All right. I guess this will be none of the two. Somebody out there somebody none of the two. So I guess I'm not right when I say I choose this one. Right? I have a dog or a cat or none. So this is somebody who would have none. So somebody who have both. But this one says no. All students who have a cat also have a dog. That's a subset situation. So I'm leading to this one now then. All students have a cat. See them here. All students who have a cat, them also have a dog. So the 12 people who have a cat also have dog. That's what that means. I'm thinking that one for now, based on that statement. Still I go eliminate. Don't jump to jump. I jump to no conclusion. See? first initial thought was wrong. All right, let's use a process of elimination. I said the number of cat persons is 12 and the number of dog persons is 16. Which of the following Venn diagram correctly represent the information? Remember, the total is 30. So you can use a process of elimination. Let's use the process of elimination. Now, this one is so wrong for me already, because them said that that's 14. The question said number and cat was 12. Cat right, let's add up to 14 right now. So that's wrong. So I can eliminate this one. Don't yes or no. But this one don't have anything where you're saying all over cat also over dog. It's a two disjoint set. This one is saying those who have cat, who have dog. That's what this one means. So this one out of it. This one was out of it from the get-go. But I think initially, so I interpreted that information wrongly. Don't you say again, this 14 make me eliminate that one too, don't it? And I told you that the number of cat was just 12. So this one out of it again. This one out of it. So the answer must be the last one. See it? And it's the one that the statement that says all over cat, also over dog. Basically, this is the point that solidifies this one as the answer. So I say another cat and dog question that different one is the answer. Let's see if I read more in this. It's another one here. Good. It's another cat and dog one here. Let's see what this one says. 30 students in this. So somebody read this now, you know, them nobody read no more, you know. But them see that, them see them say, oh, I want the answer, so I want to show the shade. I don't want to show the student in the class. And information might just be different. So assume same information and I ask you something different and presenting something different. That's what it says. Cat have a dog or none. So this is the none. People do have none. All right, it says 16 students have dog, 12 students have cat, and the remainder have neither dog nor cat. Which of the following Venn diagram below correctly represent information? Let's see. So this is now the intersection. No. Right, I'll give you the number. Let's go again. The 30 students in the class. 16 have dogs. So this is a process of elimination again. I can't look and know right off the bat. 16 have dogs, 12 have cat, and the remainder have neither dog nor cat. So you must have somebody out there. So that's what the basically says. So one of those three. All right, so let's eliminate. Them say 12 have cat, guys. And it's a 14 right now. So I'm eliminating this one. All right. Well, that one out of it. Why is this one out of it? Why that one out of it? A dog would add up all of this, and them say 16 dogs. That are 28 dogs right there. So you see that? You have 16 dogs, so you have 12 more dogs in there. So you see the 12 dogs in there, so means that 12 dogs, 12 students have dogs and cats. You understand me? Good. 28 that. So this one gone as well. What you laughing? Huh? Nobody have made the thing real. This one out of it as well. Because that's 14, don't it? And them say 12 cats and a 14 cats that. So this one out of it as well. So you see it? Answer a different ask question, same information. This was the answer. Somebody was what answer was select this, you know, and it wrong. See? So cannot do that, guys. Don't do that, please. This is the correct answer. Let's see if it makes sense. They say 16 have dogs. So you say, okay, you say, you know, tell you about no combination this time. So you say, I will know, say 16 have dogs for true. 12 have cats for true. And the rest have neither. And they add up the 30, don't it? Them numbers add up to 30. So you see, different answer. These are these choices. So there's nobody who have both cat and dog this time. That's the answer this time. Right? So you can go in the exam and say the same question. If I ask another one where this is the answer, I'm going to the answer. You can change information a little bit. So I have to look out for that. All right, over here. Set diagram. Don't give you a set diagram. Which one of these is for A intercept B complement? What is this? What is A intercept B complement? What does it mean? What does A intercept B complement mean? It just mean A only. Simple terms mean A only. You're in A, but you're not in B. You're in A and not in B. So like you're in A, the part of B that is in A, I exclude it. I don't want B. See the B complement. Remember, there's a part of B that is in A now. You don't want a part. That's why the complement of it. So like you want A, but the part of B that is in A, you don't want a part. You can't have no part of B inside. That means A only. But you understand that? Good. You don't want B. So you want A, but you don't want no part of B inside of A. You want A now, but you don't want no part of B inside of it. So like you have the A, push out the part of B in A. Right? You don't want it in there. So that means it's A only. So this means A only. Just know it like that, guys. This is A only. A only. So shaded A only. So you try to go A only shaded, right? So you say the part of B were in there, then push it out. It's not in there. Right here, so. You don't want the part of B that is in A. You don't want that part of it. It's an A. So let's write over each one. What would this one be? What would this one be? What would that one be? This would be A union B. What would this one be? These are the A intersect B complement. That's what this one. So this is the correct answer. All right. All right. What would this one be? What would this one be? What would this set diagram be? Just A. Just A. Everything in A. That's it. That is it. A. What would this one be? It's gonna be only. It's the same thing like the one up here. So that's how you go up another way. It's totally similar. So this time now you want B, but the part of A right near it, you don't want it. The part of A that is inside of B, you don't want it. So it means that you only want B only. So you want the B and you don't want none of the A. That's what that means. So it's A intersect B complement. So this is just set A, this is a B only. It's a B only. The ones it goes. Alright. This means A or B. So this means A or B. This actually means A or B. A or B or both. That's what this means. A or B or both. Alright. Alright, that does. Let's bring up the 2026 paper and see what the sets questions are on it. I'll bring it up. I want to take a break and we shall do January 2026, supposed to be here somewhere. January 2026. There you go. So I'm sure touch all them questions, the sets questions. I see same question here, so let them start early. Statistics. Right here, so that's a sets question right here. There are 40 students in a class. No, like that here it says n equal m, the number of subsets is. We should answer for this one. 2 to the m. It's a 2m again. This answer right here. 2 to them is the same question, right? That's a repeat question, right? 2 to the m. About down here. In that set A is that and set B is that. Which are the following statement about A and B is true? Same question again, not it? B is a subset of A. This one, not it? That's a repeat question. All right. We're trying to find if there are any new questions. That's 2 questions we're going to answer for and sets. 2. All right. So one here now. This one, we don't do this one yet. So let's look at this one carefully. We have not done this one. It said, according to the diagram, the number in A union B complement is what? What does this mean? What does this mean? A union B complement. What does that mean? Not in A or B. Not in X or Y, sorry. Not A union B. X union Y complement. Not in A, outside of A and X and Y altogether. So what are they? What is this referring to? Referring to the values out here. These values. That's what I'm talking about. See it? The values that are not in the union. The union, remember the union are inside us, you know. Union means inside us, you know. And the complement means outside there. So the complement on it is so means outside the union. You write that outside the union. You make a note of that. So this means outside the union. Outside the union of X and Y. So talking about this, yes, how many values there? The N in front it means number of values, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. But I give you that. Answer for that one will be 11 right here. 11. Good? Next set question. Which of the following statements best describe the elements of the subset X intersect Y complement in the Venn diagram? Which of them is this? So it's the same question up here, sir? Oh, it's the same question. The same question. 9 and 10. All right, let me take this off. So we're talking about the X and the Y. It's talking about the X and the Y. And now they are saying, what is this? What does this mean? That's the first, what does that mean? X intersect Y complement, what does it mean? It means X only. That's the first thing. X only. It's the first thing you want to know. What is X only? Let's look at X only and see which one of these is satisfied. X only will be these values in the side, so don't it? 1, 4, and 2. Put them in ascending order. 1, 4, and 2. Put them in ascending order. What are the values 1, 2, and 4? Which one of these 1, 2, and 4 represent? Are they factors of 4? Huh? 1, 2, and 4 are factors of 4. True. Factors of 4 are 1, 2, and 4. So that's what it is. Factors of 4. They're clearly not factors of 12. They're clearly not the multiples of 4. The multiple of 4 go from 4, 8, 12, and so on. Eh? So here's the answer. It doesn't make no sense. The that one don't make no sense answer upon it. Right? Remember the answers are there, guys. Pick the right one. All right. It's another sixth question here. Which are the following that appear of this joint set? We do this one already, right? What answer for this one? This joint sets. What answer? D. Even numbers and odd numbers are disjoint sets. Disjoint means that there's no intersection. Two separate sets. In a Venn diagram, that's how it would appear. Two separate sets. One for the even numbers, and one for the odd numbers. No even numbers also odd, right? Disjoint sets. All right. Checkers and scrubs again. Is this a repeat? It says, I don't make a change. Checkers on, it says, is that repeat? So which are they want to know which Venn diagram represent information. Let me see what it says. All students in a class play Scrabble. This not asked for anything, but that question we're asking us for some percentages. This one not asking us. So let's see which one it is. All right, so the play Scrabbles are checkers are about 36% play Scrabbles only. Scrabbles only. That's good. Scrabbles only. That's good. Well, this one, this one is Scrabbles only. So can I use that percent of elimination? It's a 20. That's not 36. Scrabbles only. This is Scrabbles only. Remember, so once inside, they also play checkers in this Venn diagram. So those two out of it. Using a process of elimination, those two out of it. So it's one of the top two. That's what they just said. And they say, and 40% play checkers only. See here? Checkers only. What is a checkers only? Two. Checkers only. Checkers only to that. That's what them said. Oh, so the issue now that you must account for 100%. So you say. All right. So the key thing is that you're not about the OJ stuff, don't it? Why are we not about the OJ stuff? I said all students play checkers or Scrabble or both. See that? That's why this one is wrong. That's why this one is wrong. See? Because them 16 OJs are not paying anything. That's what makes that one wrong. See that? Good. So you have to choose this one as a character. So based on what they have said. Thing just drop off while oh. So this is the answer right here. But that's not the reason. So sometimes you have to use a process of elimination, guys. Sometimes you have to use a process of elimination. Right? And the reason we could eliminate this one because the question does not allow for anybody not to be played. Check out that structures, all right? So that's 16 out there is what caused that one to be wrong. All right. Let's go. I'll put the 20 on this. It's a 20 right here. And this one wrong because the 20 and the third and this wrong because it's only. All right, so those two are. Next question says, okay, so this is consumer rated now. Let's go to this is 6 questions for you. Let's see. So we had so we started, right? 1, 2, 3, 4, 5, 6. See that? 6 sets question we're gonna get. So let's look at January 2025. Let's look at not January. Let's look at January 2025. January 2025. Since we're in January. You can look at the June afterwards. January 2025. Let's look and see. Sets question. Let's start from around here. Start right here. Is that a repeat question? Yes. Answer is D, right? Answer is D. Next one. 2-digit multiples of 6 divided by 6. Finite or infinite? This one. Huh? Finite again because of the 2-digit ones I want, right? You only want the 2 digits. Answer for that one is finite again. Let's see if it's a new question on this one. This one. It's another repeat, right? These two add too much. 29. So these two must also add to 29, right? This is already 6, so this must be 23. That's all. Good, 23 there. All right, that's a repeat question. Let's look at this one. This is another repeat question with the people who play, what is it again? Chess and tennis, right? Chess and tennis. T is for tennis, C is for chess. How many, how many, how many students play tennis but not chess? Play tennis but not chess. How many people play tennis but not chess? Tennis but not chess. Then 4 people, don't it? 4 persons, all right? Play tennis but not chess. So the answer is C. As I repeat question. It's part up here. Says which of the following is empty? Again, it's an odd and even number set, right? But this time was Q and R. See it? Q and R. See it? Q intersect R is an empty set. Q intersect R. See it here, so? There's no number that is odd and even at the same time. So Q intersect R is an empty set. That's a repeat question again. Let's see if we have any more. So one here again. There you go. Miss me dog again. All right. It said Miss D, it's me. Students in Miss Mills class have either dog or cat or none of the two. 16 students have dog, 12 students have cat, and the remainder have neither. So that looks like the question that we did a while ago. All right? Which one did we get? It's a first of elimination. So this one is not it. And this one is not it because this is 14 cats. D. So it was D. All right, remember good. Let me see why I eliminate this one. Says 12 cats and it's 14 cats right now. Eliminate that. It says 14 as well. Good. All right. So it's B is the answer, right? All right, good. Don't memorize them anymore. I might change something. Make sure you work it out. That done. All right, that's 20. Let's go 2024. Quick, and then we'll jump to 2025. After this, we take a break. 2024. 2024. See if this is no, for 2024. Let's got this one. After this, we're going to take a quick look at the 2023. All right, so let's look for the repeat question. That's a repeat question. This is the one with the H prime, right? We're looking if there's anything different. Cover our bases, right? So we did the H prime a while ago. That paper. We did it from -3 to 6 a while ago, right? It? Also, we include them. So this one, remember? We have to include them. This one we did this already as well. So them two are up to 19. So them two must all up to 19, don't it? So this has to be 4, don't it? All right. Just making sure in case there's anything new. We did the intersection here as well. We did discuss a while ago, right? I would say the shaded region were factors of 3, don't it? For that one. So which are disjoint sets. Again, it's the even and odd number, don't it? Like the dog and cat question man, see them changed again. Third stream is Miss class have either dog or cat on the month. All the students, see, put all in bold letters. All the students, me say can't have none outside. All the students who are all the students who over cat also over dog. So once you see that, you know that it's subset one. See here? It's a subset one, don't it? All the students over cat also over dog. That's a subset one. Anything else? Nope, that's it. All right, let's go to the June papers. Let's look at the June papers. We're talking about June 2025. June 2025, where are we? At the top. What's in there, so? The device. Oh, I have it in here somewhere. Let's find somewhere else. Let's find somewhere. So, here are you, June 2025. All right then. So, finding it there. Mm. I didn't put in this device yet. Sure. Oh, switch off. Yeah. 2025. Here you go. Same question again. This is June 2025. Here we go. Same question again. This one. That same range, -2 to 4 inclusive. That's the last answer down here. Different thing different. Two digit multiple divided by 6 again. That's again a finite set. Nothing new, guys. Nothing new. These two are up to 29 again. So these two are up to 29. Oh, here's a change. Here's a change. Look at this one now. This one put a complement on that now. See that? See that? That's a difference. There you go. So anybody put 23 for this now? Just dead. See that? See it? They want the complement. They want the complement. This one different. Right? They didn't want the complement, the answer would be 23, but now they put a complement on it. So they want those who are not in the union. Right? So let's look at, so if 23 is in the union, how many not in the union? Remember, the total in the universal set is 25. Total in the whole universal set is 25. And the union is 20. I agree that the union is going to be 23, but they don't want the union. So they put a complement on it now until the CSEC make it say. A lot of people go see that question and I'm after the children sign and it's wrong. The complement, if 23 is in the union and everything, everybody's 25, then the complement of the union is 2. You understand that? So here's a difference. So I'm going to go through them. See, simple as that. And put a compliment on the question different. A lot of people go and say, "Oh, the question I'm asking, sit all while. Answer 23. Marks that come up confident. Repeat question." And come to the exam and somebody said, "No, the answer 2." Then put one compliment on it this time. It's only change the method of question. Everything else stay the same. And I'm going to stick on a little compliment on it. That's all. And it's different. Answer no longer 23. The total everywhere is 25. And the union, because it's like this, you know. It's like this. Like a Venn diagram state, so you have the A, you have the B. See, you know, the union is 25. Talking about the number of people. The number in A is 14. So everything has to add up to 14, you know. So A is 14. And B, everything inside us, so B is 15. So everything in us is 15. B is 15. Then the intersection is 6. So inside us are 6. Zoom it up. Inside us are 6. So if inside us are 6, right, and inside are 14, how much is in A only? A only is how much? 14 minus 6 is what? 8. And then inside us are 15 minus 6 how much? 9. What's the answer so far? You must say everything must up to 25 now. How much is out of so far? 23, don't it? That's all? So you need 2 more that's all. 25. This is the answer that I want. This is A union B. Complement is 2. So everything must up to 25. So the answer for this one is this. So we never stop to find a change. Simple change that I want to show you. So you have to read the questions carefully. Simple to change like this. Put on a complement. And a different thing, different answer. All the same answers are there that are normally there. Right? Guys, CSEC knows so they know the question and sort the question. So they are setting up people who sort the question there. So that's when they put at the 23 but other answer there. As one of the original answers. If the complement was not there. All right? So be careful, guys. Be careful. All right. This one again, TNC, make sure they're asking the same thing. All right. And it says, how many students play tennis but not chess? Again, it's 4 persons in here, so tennis but not chess. All right. That is that. 23. Again, they're asking for the empty set or the disjoint set. Right? Empty. Which set is empty? You have to follow me to empty. The intersection of the odd and the even numbers, Q and the R. Intersection of the Q and the R is empty. There's no even number that is also odd. All right. I think that's the last one. Oh, it's the last one here, dark question. Like repeat that dark question, boy. Report for it. 16 students, dogs, 12 cat, remainder of neither. So it look like it was. What answer was it? Was D? Like D, yeah, D again, right? This one is D again. So sometimes it's this, And sometimes it is so far, but you have to look and see them change it again to make one of these the answers another time. All right? You have to make sure. That finishes the sets questions. Let's look at 2024. You can find it. 2024. Paper 1. We're talking about the June 2024 feature. 2024. All right. Let's see if there's any change on this one. So give back this one again. I think we did this one. Just the union. No, look at this one. There's that change again, guys. The one that we did before was the intersection and put us in. Hey. The one that we did before, this was intersection. It was P intersect Q intersect S. And the answer was 2. That was the answer. They have changed from intersection now. And they have now given us union. So you want now everybody, you want to set of all of the values. Right? So you want the set that has all the values, which is the last one now. Is the answer. Union of U, Q, and S. That's all the values must be involved. So the 2 must be there, the 3 must be there, 4 must be there, 5 must be there, 6 must be there, 7 must be there. So this time is union. As I look at it, my brain was telling me 2 enough, but you have to read it carefully. That is no longer intersection now, it's union. So you have to look carefully. Can't stress that enough, guys. Cannot stress it enough. It's very important. All right? Very important. Let me see what else is there. This one says the shaded region. What's the shaded region in this one? These are different questions. What's the shaded region? Shaded region is outside of the intersection. So this is the complement of the intersection. Inside at the intersection that what is shaded? The complement of the intersection is what is shaded. You see that? Complement of the intersection. See it here, so this one. The complement of the intersection is what is shaded in this one. The complement of the intersection is what is shaded. Look here, go. We have all these papers to do, have them, send them to the group. Do all of them. And also send you the answers, the solution, and so you're working on them. It don't make no sense to get exposed to these questions. And the common exam paper and get them wrong. That don't make no sense. It don't make no sense to get one question before the exam. Get exposed to it, get the opportunity to understand it and can get it and get the right answer. And then go to the exam and get the same question and get it wrong. That don't make no sense. And I'm multiple choice. That's why I expose it to every single question that I have. I have more questions than but at least back to 2010. If you want to get more questions, go down to 2001. If you exhaust all of the ones that I'm going on, I don't want more. Yeah, me have more can go. 2009, 2008, 2007, 2006, 2005, all the way down to 2001. You can go 1999, 1998, you have all of them papers there. I'm going to go to the most recent ones up to 2010. Exhaust all of those 33 papers back to 2010. And then don't tell me if you want more, I'll give you the rest of it. It don't make sense to get exposed to a question before the exam and then go get it wrong the exam. And here now I'm highlighting to you small changes that can be made on a question. Very small changes. Hard to see if you're not careful. So you cannot depend on certain answers. Understand what the question is asking. Understand how to do the questions. And do them. All right, so the answer for this one different, guys. This one would be the intersection. All right. What is them shade? What is them shade was out here? So we do that already state. We do one early. Them shade out here. So like them give you the Venn diagram and then shade around here. So answer for that one over this. Complement of the union, don't it? They leave the shade around the two things. Show you what that. the shade around here. That will be the complement of the union. See that? Give it that, and answer this. All right, that will be that one. But this answer right now is the complement of the intersection. Complement of the intersection is that one. Okay, this one. So now the one between 6 and 10, not including the 6, but including the 10, and I want whole numbers. So it looks like this one. Great. Not including the 6. So we know don't include 6, but the equal is not on the 6. You see that? They don't include the 6. But you include the 10. Equal is on the 10. Hold on a second. Hello? Yeah, morning. Oh, Allah. All right. Need to get somebody there to deal with the water. So, all right, cool. Thanks. All right, sorry about that. All right. Then we'll come to this. This one says, it's that same question again, right? We said the intersection was N. You see this one different again. This one looks different again. Hello? Yeah. All right, cool. Thanks. All right. All right, let's see what this one is. But this one looks different again. So this one says M is a subset of N. That is not true, right? So which are the following statement about M and N is true? So I want to know which one is true. But this is not true. But N is not a subset. In fact, N is a subset of that thing there. It means subset. M union, oh, this one is correct now. M union N. See this one, them change it again. So this is the correct answer. So normally give us M intersect N equals N. But this time make a change again. So it's M union N. That equals M because the union these two, you're gonna get back this set. See that? So again, there's a change again, guys. Right? A lot of people might circle this one. Remember, it's a sum equal N and circle this one, which is wrong. I've changed this from intersection to union. If that was a union, if that was an intersection, then that would be okay. That's it. So you see they're making changes, guys. You have to look out. And so the answer for this one is now this. The union is also M. A lot of people might mark that one, which is wrong, thinking that is the original question. But they've changed from a union, from an intersection to a union. All right. So that is it. Anything else? And give what this question up here. Scrabbles again, 36%, 48%. What percentage play board? This is the 16% again, right? 15% play board. 16% play board. So how many play tennis but not chess? Here again, these 4 persons. Play tennis but not chess. I've seen them ask question already where this is answer, right? All right. I'm going to play both tennis and chess with these. I finished that paper. Which paper is that? 2024. All right. That is it. I'm going to take a break. How long break do you want? It's now 12 o'clock. Want to consume arithmetic after the break. What break do you want? Talk fast. Put up the clock. Huh? 10 minutes? I'm going to give you 15. Consume arithmetic is 8 questions per paper and a lot of questions. And a lot of the questions require a good amount of work. But I also would have finished today. Huh? 1? We'll go past 1. Hush. We're going to go past 1. Maybe 2 o'clock. So we're going to take a 15 minutes. And then we'll come back. Let me put up the clock. I leave 4 minutes time I start. All right, guys, let's go again. Consumer marketing. I think this is the question on the paper that requires the most let's say tedious calculation that you have to do without a calculator. And so I like to tell the student that remember the answers on the paper. So when you read the question and look at the answer, don't just go working out. Because a lot of the time you don't have to work out everything fully to know what the correct answer is. All right? There are like some signals of which answer is the correct answer. You don't have to work out everything fully most of the time for these questions. All right? You can see what the correct answer is without working with everything. All right? But it's a good, you good to good to practice some of the strategies I'm going to show you and some things they can look out for. All right. Well, let's go. Let's just do them and I explain as I go. Let's look at this first one. It's consumer arithmetic. Just relating to money. Let's put it that way. Money related question. Eh? Question says for every $100 or part thereof, a salesman is paid $10 as commission. So for every $100 or part thereof, meaning if you don't reach $100, it still get paid a commission of $10. So every time you reach $100, he gets paid a commission of $10. And if you go over the $100, he start get a commission again of $10 more until he reach $100 again. You get me? So if it says in a particular month is $1,020, how much commission did he earn? Remember, it's getting a commission of $10 for every $100. That's the first thing. So they want to know how many $100 in this. So you can take this $1,020 and say, okay, this $1,020 is $1,000 plus $20. For everyone, there are 10 $100 in this. So it becomes 10 times $100. There are 10 $100 in this, plus the additional $20. Let's put the commission in red now. He's gonna earn $10 for every $100, and it's 10 times him earn $100. So this is the commission now that he's getting. The commission is 10 times $10 first, plus he get another $10 for that part thereof. Another $10. Understand that? Right? So he earns 10 times $10, that's $100 plus another $10. That's $110. See there, this is the answer. Understand that? Wanna go to that? Understand? Next question. It says the value of a plot of land is $18,000. Land tax is charged at a rate of 70 cents per $100. What is the total amount of land tax? Or what is now? I can look at these numbers, right? And say that all the digits in these numbers are different. Materially, the answer is going to be that's 18 times 7 or so. Whatever 18 times 7 is in terms of the digits is the correct answer. But all the values are in hundreds. See that? All the values are in the hundreds, don't it? But they are different. Materially, to work this out, you're going to have to multiply that 18 times 7 some way, somehow to get the answer. And whatever the 7 times 18 is materially, because I see there's other zeros. There's a matter of where the decimal places, whether the number is in the tens, the ones, or the hundreds, or whatever. That's what those other zeros do. Materially in working this out, significant value, the significant values in this calculation is 7 times 18. 7 times 18. So I already know the answer is what is 126. How many know? Because 7 times 8 are 56. And the only way we can get a 6. So we have to work out this. That must be the answer. But let's say you have to work it out. So you want to understand it. So that if them change the values, you can still know what to do, right? So it says, so the value of the land is $18,000. And for every $100 in there, there is a tax of 70 cents. So basically, you want to know how many $100 is in this. So divide by 100, and then for each of them $100, you multiply by the 70 cents. So the tax for this is going to be the 18,000 divided by 100. That's the number of $100 that's in this 18,000. And then for each of them $100, you're multiplying it by 70 cents. 0.70. That's the calculation. Right? This represents the number of $100 in 18,000. And for each of those $100, you're paying 70 cents. That's the calculation. So you see, in doing this calculation, these zeros cannot cancel each other along the way. The numbers that you actually multiply The number that you actually end up multiplying is the 7 times the 18, somewhere along the way. And based on those answers, the only number there, so that is the product of 7 and 18 is the 126. All right? But if you have work it down, sure you can cancel this down. Pay attention. Firstly, okay, remember, you can't calculate an exam. So be smart, right? So you cancel out 2 zeros out of this and 2 zeros out of this. This becomes 180, right? Times this. Watch this now. I don't want to work with no decimal. Multiply with no decimal. You see the 0 on this 180? I can apply it to this 70 because the 180 right here is same as 18 times 10. So I can take the 10 times this 0.7 and turn it into a 7. See that? But in short terms, I can say this 80, this 0, I can cancel this 0 and turn this into a 7. And I'm going to multiply that 0 here by this. Then I'm going to multiply this 0 at 10 times the 0.7 becomes 7. So the answer becomes 7 times 18. Right? That's what the works on. 7 times 18. Or 18 times 7. That's what I end up with. 18 times 7. Right? That sign as a cancel with this one. So it's 18 times 7 end up with. Or you multiply 18 times 7 picking an exam. You can do 10 times 7, that's 18. 18 is 10 and 8. So 10 times 7 and then 8 times 7. You can look at it that way. If you want to set up the normal, you have the 7 times 18, and you get 56, 7 ones, 7, 5 is 12, 126. Right? Anyway, you want to work it out, answer is 126. But you could also recognize the 18 times 7 as 10 times 7 plus 8 times 7. The 10 times 7 is 70, and the 8 times 7 is 56. And they add to 126. So the answer is this one. But this is a question I could have gotten the answer without doing no work at all. And I look at the numbers and realize that I'm going to have to multiply these numbers at some point. Right? I'm going to have to multiply those numbers at some point. So materially, the value that you're really multiplying is 7 and this 18. 7 times 18 is 126. Right? And so the only answer with a 126 in there is C. So that C had to be the answer. All right, let's continue. This question down is a simple interest question. Now, you must know the formula of a simple interest. It is I equals PRT divided by 100. That's the formula of a simple interest. I equals PRT divided by 100. Shift this up a little bit. Now remember, this formula is not only used to find the interest, guys. You want to find the rate, you have a transpose. The principal of me. You want to find the rate, you have a transpose. You want to find the time, you have a transpose. Any one of these things you want to find, this formula can be used. Just transpose. But that's the formula you start. For simple interest, I equals PRT over 100. Now, the time has to be in years. But the rate is always a rate percent per year. And when they give the rate as a rate percent, for example, if they give you 5% as the rate, then the R is 5. The rate is 5%. The rate is 5%. Interest rate is 5%. Then the R equals 5. The percentage part is already taken care of with the 100 on the year. So the R will just be 5. All right? So the percentage part of the rate is already taken care of with the 100 that's under there. So expect it to be given the rate as a per year, because the time is in years, and the R is a percentage, the rate is a percentage. Let's see what it says. So you're looking out for the various value. So this question, the simple interest on 8 on 900. So this is the principal. This is the principal right here. This is the P. For 3 years, this is the T. That is the T. The time is T. 3 years. And this is the interest that they gave you. And I want you to find the rate. This question is asking you for the rate, R. This is the rate that you're trying to find. So if you want to make R the subject, you just transpose away the P, bring it under here, transpose the T under here, and take the 100 and multiply it up here. So you're going to get that the rate is now equal to 100 times the interest, you multiply the 100, and then you take the principal and the time and you divide them on this side. What the principal times the time. Repeat the value stuff. Therefore, that rate equals 100 times the interest of 108 divided by the principal of 900 times the time of 3. That's what you're working with. And just cancel that down. Cancel it down. Or you cancel this down, okay? Cancel the calculator, so you cancel it, right? So we're gonna go 100 into this, into 100 goes 1 time, 100 into 900 goes 9 times, right? Then I can say this 9, this is 9, right? I can say 9 into this goes 1 time, 9 into 108 goes 12 times. Then 12 divided by 3 is 4. 12 divided by 3 equals 4. So the rate is 4%. So anyway, just sit to cancel it down, no problem. Just cancel it down. You can't calculate. So you have to cancel it down. Next question. It's another simple interest question right here. Same question, but this time they give you the rate. And ask for the time. So the time is going to be 3 years. The same question, you know, and they reverse the values. See? So this time they give you the same rate of 4% that we just work with. The same principal, the same interest. So it's the same question, really. Right? So it's the same thing. I equals PRT over 100. This time you don't know the time. It is the time you don't know. So again, I'm going to take the 100 and multiply it up here. You're going to get 100I divided by this side, divided by the P and the R. That leaves the T as the subject. Principal and the rate. That equals the time. Plug in the values now. So time equals 100 times the interest of $108. Divided by the principal of $900 again. Times the rate of 4. Rate is 4%. 4. You don't put 4%, just put 4. When the percentage is 4%, R equals 4. And you can send this down again. And the answer is going to be the 3 years. Answer is going to be the 3 years. That's the same question, same values. So this cancel into this again 9 times. 9 into this again, give you 12. And then 12 divided by 4 is 3. This time. So the time is 3. Simple as that. All right? 3 years. So the answer for this one is 3 years. All right, next question. It said at the end of a year, a car is worth 5% less than it was worth at the beginning of the year. So listen, guys, we have to work percentage this way. If you're taking off 5% off something, it's 95% average. If you're adding 5% to the value of something, it is now 105%. If you take off 10% off of something, and 90% average, 90% of the original. If you add on 10% on the value of something, the new value is 110%. So if this thing is 5% less than it was worth, it is now equal to 95% of the original value. And that's at the beginning of the year. It's 5% of the beginning of the year. If the car is worth $9,500 in December at the end of the year, that's the final value. You know? So that value in December is a 95% value. What was the January value? What was the value in January? See here? See here? 95% of the January value is now the December value. The December value is 95% of the January value. And the December value is this, 9,500. You don't have to calculate 5% of no. Just know that the December value is 95% of the January value. You're trying to find the January value. Set up equation like that. 95% is 95 over 100. So this is 95 over 100 times the January value is equal to the December value of 9,500. The December value is 95% of January value. That's what happens. And you're trying to find the January value. So what you're going to do to find it? You're going to take the 100, multiply it up here, take the 95 and divide it under there. So the January value is going to be 95,000. 9,500, sorry, times 100 divided by 95. The 95 come under here. So that is it. So you can't cancel again. 95 into this goes one time, 95 into this goes 100. You have 100 times 100, that is 10,000. 100 is 10,000. This becomes 10,000. The dollar sign on it. Answer is 10,000. That is it. Simple as that. What good? If you learn to do percentage that way, easier. All right? Nobody calculate the 5%. Just don't say if you take off 5%, the value take off left 95% of what it was before. All right? Next question. A man regular pay is $3 per hour up to 40 hours. $3 per hour up to 40 hours. That's the regular pay. So that's $120, right? 3 times 40, $120. It says overtime is twice the payment. Overtime is twice the payment for regular pay. So overtime rate is $6. It says if he was paid $216, how many hours overtime did he work? So you have to subtract the overtime, you have to subtract the regular pay from the total pay to see what the overtime pay was. All right, so let's set it up. So the regular pay is $3 per hour times 40 hours, which is equal to $120. That's a regular pay. So this pay includes overtime. And so the overtime pay, let's call it OT, the OT pay becomes $216 minus $120. What I work out to? That's 80 plus 16. That's $96. Agreed? No, 196, not 96. $196. No, 96. I'm gonna work that out quick. Because I have $120. I'm going to reach 216. I have to add 80 first, reach 200. And then I add 16 more. Add 16 more, reach 216. So I add 80 and 16 at 96. So $96, right? But I get that? $96. All right, so that's the overtime pay. What is the overtime rate of payment? It's twice the regular pay. See, you know, the overtime rate is 2 times $3, which is $6. So its overtime rate is $6 of pay. So he earns this amount of money You're looking at $6 per hour. You're looking at $6 per hour. So to know the overtime hours, you're going to divide this overtime pay by the overtime rate of pay. So the OT hours becomes $96 divided by $6 per hour. What I work out to? What I work out to? 16. 16. 16 hours. Divided by 6 again, 16. 6 into 9 goes 1 time remain at 3. 1 remain at 3. 6 into 36 goes 6 times. I can't divide 36 by 6. Divide it out. 96 divided by 6. You can't get a calculator. 1 remain at 3. Right? 6 into 30 goes 6 times. Come on. You can't do that calculation there. So 16 hours overtime you did. 16 hours. That is it. All right? All right, let's continue. It's the same kind of question here, so. A man regular pays $8 per hour up to 40 hours. Same question with different values. Overtime is twice the payment of a regular time. So the overtime rate is going to be $16 per hour. So the same question with different values. All right? If he was paid $480, how many hours overtime did he work? Same calculation. So the regular pay, just tell me now, the regular pay is how much? What's the regular pay? $8 per hour for 40 hours. How much is that? 8 times 40 is how much? 320. So if we work a total of $480, what is the overtime pay? What's the overtime pay? How much? 160. 480 minus 320 is 160. Good. $160. What is the overtime rate of pay? Overtime rate is what? What's the overtime rate in this question? The regular rate is $8 and the overtime rate is twice. No man, dollars is overtime rate is $8 per hour and it's now paid overtime as twice that payment, twice that rate. The regular rate is $8 per hour. Overtime rate is 2 times that. So that's $16. The overtime rate, overtime per hour is $16. $16 per hour. Therefore, the overtime hours is what? 10. Work total 160 hours, $160. Working at $16 per hour. So you work for 10 hours overtime. 10 hours overtime. So answer here is 10. Yeah? All right, good. Let's look up here. This question says simple interest on $600 for 2 years at 5% is $120. What is the value of T? Same kind of question again. But look at the answers, guys. We're not working out everything. We're just trying to get an expression for the T. See that? We want an expression for the T. So start again. I equals PRT over 100. You must remember this formula for simple interest. PRT divided by 100. You want to find the time. So you transpose everything away from the time. Multiply the 100, divide under the P and the R. So 100 times the interest over the principal and the rate equal the time. So put in those values in there. The interest is 120, principal is 600, and the rate is 5. So put in those values. So it becomes 100 times the interest of 120 divided by the principal of 600, and the rate is 5. That equals the time. Look at the matching this now, you go. Which one? B. The answer is B. So you see, we have to look at the answers, guys, because remember, this one not working out. Leaving the answer as a formula, as an expression. You're not working it up. You can come over here, sir. All right, next question. At a bank, EC $2.60 is equivalent to US $1. All right. So for every $1 exchange, $1 exchange, EC $10 is deducted as exchange tax. How many EC dollars will Leon receive if he exchanges 1,000 US dollars? So note he's only receiving $2.50. Guys, out of the $2.60, he's paying $10, 10 cents, as a tax. You understand? So he's receiving $2.50 for every $1. So he receives for US $1, he's receiving EC $2.50. But I can understand that EC is $2.50. So they get. I'm paying over 10 cents to them as a tax. The question is interested is how much he receives. How much he receives. So for every $1, he receives $2.50. So for $1,000, you just need to multiply it by 1,000. See that? Get that? Multiply it by 1,000. So for $1,000, we just need to multiply this ratio. We treat exchange rate questions as ratio question. Multiply by 1,000. So this is my point. Move 3 places to the right. Right? So it becomes 2,500. This answer right here. But understand that? But good at that? Yeah? All right. Next question. A calculator was marked at $120 and it is sold for 30% discount. So for a discount of 30%. Remember, if you set at a discount of 30%, it means that you're selling for 70%. Right? Let's say again, a calculator which is marked at $120 is sold for cash at a discount of 30%. How much change would Susan receive if she pays for the calculator with a $100 bill? So the amount for the calculator is going to be 70% of the $120. 70%. All right? So the change is going to be $100 what she give them minus 70% times the amount for the calculator. Tell me if you don't understand. This is the amount she paying for it. Because she get a discount of 30%. You don't have to work out the 30% discount that she get. You need to work out what you pay for it. She pays 70% for it. She get a discount of 30%. She's paying 70% for it. So this is the amount that she's paying for it. And she give them $100 and she want to know what the change is. So $100 minus how much they're taking out of the money for it. So 70% of this is how much? 70% of 120. No, eh? 70% of 120. So in the exam, you want to work out 70% of what? You can do your 70 over 100 times 120 if you want. This cancel this. It'll be 7 times 12 is how much? 7 times 12 is how much? 84. So it's 84 over 10. So it's what? $8.40. 84 over 10, $8.40. So it's, I don't know, $8.40. Let's go again. 70%. 70, not 7. 7 over 100 times 120. That's what this calculation is. Right? That's $84. But I say $84 that? Because material it becomes 7 times 12. But all those zeros cancel in. Look. That zero cancel that zero there, and that zero cancel that zero there. So it becomes 7 times 12. That's $84. And subtracting $84 from $100. How much you have left? $16, right? $16 is left. So it becomes $100 minus $84. That's $16. So the key thing here, guys, you do have to calculate 30% first. If you do something by 30%, it's 70% that is left. If you do something by 10%, it is 90% that is left. So you have to waste time working out the 30% first, and then I'm going to subtract it anyway. That's additional work. Let's work out the 70%. You get me? Let's work out the 70%. Become fast. Right? That is it. Next question down here. Similar kind of question. If a store offers a discount of 15%, it's a 15. Offers no a discount of 15%. So much you paying for this? How much you paying for the thing? You get that discount of 15%. How much you paying for the thing? Huh? No man, 85. Right, 85%. You get a discount of 15%, you're paying 85%. That's the first thing you want here. Don't worry for the 80%. Alright? Alright. So a store offers a discount of 15% on the total bill to customers who spend more than $20. So this is $20. So anybody who spend more than $20 paying only 85%, they get a 15% discount. If the customer's total bill is $80, how much, if the total bill is $80, how much must she pay? She's gonna pay 85% of $80. That's getting a 15% discount. But understand that you have to work out the 15% first. There's no such paying 85% of $80. So she paid 85%. She paid 85%. Times the $80. That's what she pays. Right? Now we can work out 85% quick. Materially, but those numbers are different. You will want to multiply 8 times 85. That's what you want. 8 times 85. Materially, those are the values you want to work out. 8 times 85. But you can work out 8 times 85 quick in an exam. 8 times 85 quick in an exam. You can work out. You can 8 times 85. You can work out 8 times 85 quick. 8 are 64. Well, I know 85. Hold on. We're going to divide by 100. We want to know what the material value is, right? We can work out 8 times 85 quick. Well, you want to know what the value is. Huh? 680. So you're looking for 68. So 68 right or so. Well, let me show you can work. So you do 8 times 80 first. 8, 64, right? 64, right? And then 8, 5, 40. So you get the 680 like that. And do it in parts, right? And do it in parts. But this will work down. If you canceling it down, cancel 0 for this, right? And then you could work this out and then divide by the 10. Right? Work out those two and then divide by the 10. Right? Work out this time this, and divide by the 10. So you will get this. You will get the 8 times 80. Can break it down enough. 8 times 80, because this 8 is 80, and then 8 times 5. 8 times 80 is 640, plus 8 times 5 is 40, all divided by 10. As he said, it's 680 divided by 10, which is 68. So this is the answer right here, 68. But the thing is, they cannot use the calculator. The exams, you have to be able to work on these things. You have to take it. Everybody understand what us calculate 85% though. But you get a discount of 15%. So only paying 85%. You do have to calculate the 15% first and then subtract. Just calculate 85% straight. You want to calculate the 15% and then subtract? Fine. All right, but if I understand percentage like this. It says at a store, sales tax is charged at a rate of 2% on the cost of an item. The sales tax on a dress costs at $180. It's $180. So the sales tax is 2%. And they actually asking for sales tax. So you want 2% of this. Look at these answers now. The word is out, you're gonna have to multiply. Look. You're gonna have to multiply this 2 by this 18 along the way. 2 times 18 at 36. The only number that's with a 36 in it are this. So this have to be the answer. That's the only number with a 36 in there. That has to be the answer. You get me? So sometimes you can look at the material, the material values in the calculation. The material value in this calculation is the 2 times the 18. The 0 here, so, and the percentage, which is mean 2 over 100, it doesn't matter where the decimal point is going to end up. But materially, you're getting a 2 times 18, which is 36. The only value with a 36 in it, in these answers, is the first one. So that has to be the answer. You don't have to work out everything in an exam. Once you realize that you're going to have to multiply the 2 times the 18, you're going to get a 36 somewhere in there. Just what that's 36, 3.6, 360, 3,600. Once you know, so the answer is going to be something with a 36 something. Or even 0.36. The only answer there with a 36 at the first one has to be the answer. You don't have to work out everything in the exam paper. The beauty about multiple choice is that the answer is there. So as you work, you're looking at the answers. It's a special question where all the values, the digits in the answers are different, like this one. All the digits different. We're looking for the one with the 36. Has to be the correct one. You don't have to work out everything on a multiple choice paper, guys. You don't have to work out everything. All right? I'll show you another thing now. You want 2% of 100 and you want 2% of 180. All right? Watch this. 10% is 18. If you have 180, then 10% is 80. What about you with that? 1% is 1.8. 1% is therefore 1.8. Let's break it down like that. 1% is 1.8. So 10% is divided by 10. 1% divided by another 10. So if you have 180, then 10% is 18. 1% is 1.8. Keep divided by 10. Understand that? So 2% must be 2 times this. If 1% is 1.8, $1.80, then 2% has to be 2 times the 1.8, which is 3.6, $3.60. So this has to be the answer. All right, so multiple ways to work this out quickly. Key thing is to be able to work them out quickly. Can't depend on swatting as I showed you in the first part. You miss a whole thing we set that we worked out. Can't depend on swatting if I did make some simple change. Look at that girl last question that we did. We did about, we saw that question about, we saw that kind of question about maybe 20 times, don't it? The last one we looked at, then we put on one little compliment on the something so. And the difference. That's all they added to it, a compliment. In 2026, January. One little change. Every time I do the answer 23, 23, 23, 23. And then all of a sudden they make one simple change yourself. And the answer different. So you have to read carefully. All right. So if 1% is that, then we know that 2% is twice it's 360. All right. So one here. And let's continue. Next one. Said a man's taxable income is $20,000. In other words, you can charge tax on that. He pays tax at a rate of 28%. The amount of income tax paid is what? It's again easy. Because you only really multiply this 2 for this question. Materially, you're multiplying this 2 with this 28. And so, the answer must be the one with 56. You don't have to waste time and work that out. You don't have to waste time and work that one out. He's paying tax of 28%. And it's 28% of this. So 20% of this. Materially, the value we're working with are the 28 and the 2. 2 times 28 is 56. The only answer down here with a 5, 6 at this. Must be the answer. I'm not have to work out nothing. That must be the answer. If you want to work it out, you might guess. So you want 28%, which is 28 over 100 times 20,000. You don't have to do this, guys. Materially, the only values that are important are this and that. Them 0, 0, so. It's a matter of where the decimal point go. Whether the answer is in the ones, the tens, the hundreds, the tens, the 100, or the 1,000. That's what those zeros do. But materially, the values that are important in this calculation is 2 times 28, which is 56. And the only answer there with a 56 is the 5,000. And all of these in the thousands anyway. So it must be the C with the 56. The answer is on the paper, guys. As you work, looking at the answers are on the paper. Right? So you're not working everything fully out. You don't need to work out everything fully. When the answer is there looking at you. All right? Remember the answer is always, as you work, you're checking out the answer. This question says, a man's basic wage for 40 hours. Same question, I'm changing up a little bit, you know. A man's basic wage for a 40-hour week is $106. So based on that, the rate of work is $4 per hour, right? This total wage divided by the 40 hours give you $4 per hour. Agree with that? That is rate, working rate, or wage rate. $4 per hour. He pays $5 per hour overtime. So he pays $5 per hour overtime. If you work 6.5 hours overtime in a certain week, his wage for that week is what? This one easy. So his wage for that week is going to be the basic wage plus the overtime wage. And the overtime wage is going to be the 5 hours per hour times 6.5 hours. See that? So it's going to be paid the basic wage of $40. Let's work it out right here. So it's going to be paid the basic wage of this first, 160, plus the overtime, $5 times $6.5, 6.5 hours. Overtime is $5 times 6.5. That's what you're working on. We work out 6.5 times that quick in an exam. 6 times the $5 first. Look, so it's gonna be in the exam, I can't calculate, right? So it's 160 plus 6 times the $5 first. 6 5 are $30 that. Plus half of the $5. Half of $5 is $2.50. That's what they pay. This becomes $32.50. This must be the answer. That's $2.50 in it. See there? This has to be the answer. See that? That's 160 plus the 30 or 190 that already. It was $2.50 more. But the important thing is working out this part quickly. Look at it. It's a 6 first times the $5, and then the half times the same $5. That's the 6.5 times 5 enough. So it's the 6 first and then the half. Work it out. Work it out quickly. That is it. I think these are the same question written a different way. So they give you the overtime now as 1.25. The same $5 this per hour. Why is that? Because if the regular pay is $106 in 40 hours, then the wage rate becomes $160 over 40 hours. That's $4 per hour. Is a wage rate. And now it's paid time and a quarter. 1.25 times the overtime. It's overtime rate. So the OT is 1.25 times the regular of $4. That becomes $5. Because first, so the 1 times the 4 is 4, and then a quarter of 4 is 1. You see that? So the 1 times the 4 is the $4 first. And then a quarter times the 4 is $1. That becomes $5. It's the same question, you know, guys. The same question, but in this question, they gave you the $5. Now they tell you at a time and a quarter, but it's actually the same question. See, there is 6.5 hours tomorrow for again, same as over here. So it's the same question. It is the same question. But this time you have to work for the $5 for yourself. Here they give it to you. Right? See, if you work 6.5 hours over time, his wage for the week is what? Same calculation as this. Same answer. Same answer. Same answer. Just for this one, you have to work out the $5 yourself. Overtime week yourself. See that? It's the same answer. All right, so that's on a different exam paper. The same question on a different exam paper. Right now, like a bit different. All right, let's look up here. This one says, excluding sales tax, how much will be saved when a video which costs $12 is sold at a 20% discount? How much is saved? 20%. You save 20% because that's at the discount. That's how you save the discount. The amount that you save is the discount. This one easy again. Materially, you're multiplying. Well, you have a careful now. You have a 2 4 and you have a 2 4 display. See that? One of them two there inside. So you want 20% of $12. So you want 20% of $12. So 10% is $1.20, don't it? So 20% is $2.40. See that? So you can do it that way. 10%. So you're actually doing 20% times the $12. Right? 20% times the $12. That's what you want. Huh? 20 over 100 times $12. Right? $2.40. I could say 10% is $1.20. Therefore, 20% is $2.40. So the answer is this one right here. All right. Next one. A store offers a discount of 10% to a customer who spends more than $20. If the customer's bill, we do this one earlier, right? The customer bill is $80. What will you actually pay? You might pay 90% now, 10% you might get off. If a customer is offered a discount of 10%, it means he's paying 90%. Right? If you spend more than $20, if you spend $80, then you might get a discount. What is the actual bill? Is actual bill going to be 90% times $80? Now this is easy again. Materially, I'm multiplying the 9 times the 8. 9 is 72. So any answer with the 72 must be the answer. See that's all? I don't only 72 that. We don't have to work out nothing. Because the answer is on the paper. This is the only answer with a 9 times 8 value. See there? That must be the answer. Now work it out. Materially, you're multiplying 9 times 8. 9 times 8 is 72. The only answer with 72 in it is this one. So that has to be the answer. You don't have to go any further, guys. But I agree with that. You don't have to realize that, guys, because the answers are there. You cannot be working the question and not looking at the answers. You cannot be working the question and not looking at the answer. If you want to work it out, no problem. Right? So 90 over 100 times 80. You can see they get the 9 times 8 and it up. A 0 cancel that 0 there. A 0 cancel that 0 there. See, you end up with 9 times 8. 72. You could do it from before. You didn't have to do this. 72. All right. That finishes that one. When I get to the other people, I'm going to notice some of them. 2026 and so on. Eh? This one said, a man pays 60 cents. Now, say them cents business there, change them to dollars for me, please. I say all these answers are in dollars, change them to dollars. So this 60 cents is $0.6. $0.60. Working dollars. But the answers are in dollars. All right, so it pays 60 cents or $0.6 for every 200 meter cube of gas used plus a fixed charge. So for every 200 meter cube, it's paying $6, 60 cents. So if you use 400, you pay 2 times this. If you use 600, you pay 3 times this. So for every 200, it pays this. He pays that, right? Says if he pays $178.75 for using this amount of gas, how much is the fixed charge? So what we need to know is how much he pay for the gas out of this money. And subtract how much he pay for the gas out of that money, the difference is the fixed charge. But understand that? So how much he pay for the gas? We want to know how many 200 is in this. And if each of them 200 there is paying this amount of money, look at it. So let's work it out as the gas charge. Gas charge becomes equal to space we have, right? This amount total is 55,000 divided by 200. That's the amount of 200 that is in this. And then for each of those 200, he's paying this amount of money. 60 cents. That's his gas charge. But understand that that's his gas charge. Total gas that he used divided by 200. That is a number of 200 that is in this. And then for each of the 200 is paying this amount. You want to know how many 200s is in this? 55,000 divided by 200. That tells you the number of 200s that is in 55,000. Then for each of those 200 is paying this amount of money. Tell me if you understand this calculation here that's on the screen. For the gas charge. Understand that? That will tell you the gas charge. So we need to cancel this down and see what this is mean. Let's go. So in the exam, I can't use a calculator. Let's cancel it down. So firstly, 2 of them 100, you cancel 2 of them 100 here, right? I don't like to be working with these decimals. So you see that 0 left on this? You apply to that 0.6 and turn it into 6 with this 0. But understand that? You don't understand that? Let's show it. Let's make it clear there. Because this 0 makes this look like 555 times 10. And the 10 times this 0.6 turn it into 6. So we have 55 left. See that? All right, let's go back. Now we're going to do all that. So that 0 here is like 55 times that 10, right? So I cross out that 0 there. I got 10 times this gone, turn it into a 6. You see it now? Then that 2 into that 6 now make this a 3. See that? So I'm doing 3 times 55. 3 times 55. Watch this now. 3 times 55. 3 times 50 first. Right? 3 times 55 is the same as 3 times 50 plus 3 times 5. You can see that? So 3 times 50 first is 150. And then the 3 times 5 is 15. Tell me if you say that. But I say that? That becomes $165. $165 is the gas charge. In the exam, you have to be able to do this calculation. If you want to set up and put the 55 times 3 like this and the irregular thing, and the 3 times 5 are 15, carry 1, 3, 5, 15, and 1 makes 16. If you want to do it that way, that's fine. No problem. Right? But me, like, look at it and say, okay, I'm doing 3 times 65, 3 times 55. That's what I'm multiplying. 3 times the 50, and then 3 times the 5. 3 times 50 is 150, 3 times 5 is 15. I then get 165. So that is the gas charge. But this was the total charge. So the fixed charge is total charge minus the gas charge. See that? Watch this now. The answer must be the one with a 70.75 on it. Has to be this one. I'd have to work it out. How many know it must be that? Watcha. Look here. If you have to do this minus this now, has to be the answer with the 0.75 on it. Don't it? Because me I do 178.75 minus a whole number of 165. The answer must have 0.75 on the answer. That's the only answer with a 0.75 on the answer. See it? So you don't have to actually work it out based on those numbers. Right? Must be the one with the 0.75 on the answer. Must be that one. So I'm doing this value, 178.5 minus this value. The answer must have a 0.75 left on it. We're done. The only answer with a 0.75 left on it is this one. That has to be the answer. You could work it out still if you want. But I'm telling you, not everything has to be worked out. Not when the answers are there looking at you. Has to be that one. So the fixed charge would be the 178. If I say now, for them show them working here now. Minus 165. This not for work out because it's have a 0.75 on it. So the number you minus that number you must have a 0.75 in the answer. That's the only answer with a 0.75. That doesn't have to be worked out. But good? All right. This question says a plot of land presently valued at 12,000 appreciates. Appreciate means what? Grow in value. Appreciates at a rate of 2.5% per annum. What will be the value of a plot of land after 1 year? What's a question I know? Now, if you do no work at all on a question, because if something appreciates, you cannot really question and not look at the answers. Why is it that we can't eliminate them 3 answers here? Why? Huh? Because those are all decreases. You know, if you record nothing for a question, the only value that is greater than 1200 is this last one. That has to be the answer. That actually cannot be. Because the value appreciates, mean got more. That's the only value that is more than 1200. You see it? So I'm telling you guys, not everything has to be worked out. Right? Not everything has to be worked out. So this one don't need no calculation. So the value must be greater than 1200 because it appreciates. The only value greater than 1200 is this. I'm not calculating nothing. That's it. Done. If you actually calculate on this one, you're wasting time, giving away time. If you think appreciates, it cannot come less. All of these values are less than 12,000. The only value greater than 12,000 is that one. That must be the answer. Must. Can't be none of the others. That something get appreciated, grows in value. Get more. You have to work for not for this one. Be smart. The answers are there on the paper. You cannot read the question and not look at the answers. You have to look at the answers. Read the question and look at the answers that are there. And start eliminate right away. So this one don't need no work. Waste of time to work on this one. Next one. A loan of $8,000 was paid back in 2 years in monthly payments of $400. So you paid monthly. You have to realize now that this 2 years is actually 24 months. They're paying in monthly payments of $400. The interest on the loan as a percentage is what? So you want to know what the interest is. All right. So the interest is the total repayment minus the 8,000, don't it? So let's look at it. So you repay 24 times he paid $400. 24 times he paid $400. So it's 4 times 20 first. 400 times 20, that's 800. And then 1,600 more. So that's 1,600. You want to work 4 times 24. 1600. 1600, add on 100 afterwards. So it's 4 times 24, that's 96. 96. So 4 times 20 is 80. Then 4 times 4 is 16. 96 that, right? And then add on the 200 then back on it. So that's 9600. Can't use a calculator in the exam, guys. You have to go fast. You have to learn to go quickly. So if I'm multiplying these two numbers, right? This and this. I leave out the zeros for the end and just work out the 4 times 24 first. 4 times 20 is 80, and the 4 times 4 is 16. Add them, I get 96, and then add on back them 200 here upon it. Them 200 here. So that's like 9600. 9600. It's a calculator. That's 9600. So the original amount was 1800, then the interest is equal to 1600, don't it? But have you heard that? 9600 minus 8000 must be 1600. That's the interest. But I want this interest as a percentage of the original amount. So see here now, the percentage interest becomes the interest of $1,600 over the original amount, which is $8,000. Multiply that by 100. That has to be 20%. Huh? Where's it? Yeah, my cross that. It has to be 20. I'm going to say it must be 20. Because materially, dividing 16 by 8, which is 2. So the answer must be an answer with 2 in it. That's the only value with a 2. Them other zeros here. Only determine the size of the 2. But a 0.2, 2, 20, 200, so must be something with a 2. So there are 0.2, 2, 20, 200. Something with 2. So the only value with just 2. So that has to be the answer. I don't have to actually work this out and waste time. Because materially, this question, you're really only dividing the 16 by the 8 to give you a 2. And then other zeros, as we say, just a matter of weight. But we work out to 20% still if you want to work it out. So that says 20%. So if you can't sit down and waste time and work it out, fine. But remember, guys, I always say the answer is on the paper. The answer is there. So as you work the question, you're looking at the answers, and you realize that this is about gear material value of 2. The only answer with that 2 in it is this one. So that has to be the answer. Can't be none of the other ones. Only value with a solid 2 is that one. Right? So that is it, guys. Be smart. Be smart. Be smart. You finish the exam quickly, you have time to come back and really check these things. Key thing, you want to finish the exam like in half an hour, 45 minutes. And then the next 45 minutes, go back to and check everything. Check everything. You want to do the paper 3 times in the exam, do it first, and then come back to and do it again, and go back to 1/3 time. You're supposed to be able to do the paper 3 times. If you can't do it 3 times, at least 2 times. Go through every question twice, at least two times. All right? A lot of the questions will repeat. A lot of them will repeat. Not exactly close enough. An article bought for $125 was sold for $175. That's a profit of $50, right? The profit as a percentage of a cost price is 50 is the profit. Obvious, right? It's from this. 50 is the profit over the original amount of 125. Multiplied by 100. That's what you're working out. Right? So you can divide this up by what? 25? 25 into this goes 2 times, not it? 25 into this goes how much? 5 times. So the answer must be something with that 4, don't it? Must be this one with that 4. Because I say 5 into this goes 1 time, 5 into this goes 2 times. So it's the one with the 4. Oh, you're right, yes. Want to go to that? All right. Same thing as an article is bought for 125 and sold for 100 now. So now you have a loss. It's a percentage loss now, you know. You're dropping off $25. So the loss is $25, right? The loss of the percentage of a cost price is now 25 is the loss over cost price of 125 now. Multiplied by 100. That's how you're working out now. So 25 and this goes one time, 25 and goes 5 times. And then you go, this is 20 now, right? That's 5 until this goes 2. 20. So the answer is this one. Right? So the loss divided by the cost price. Because always over cost price, guys. You don't put over 100 in it, put over 100 around. Put over the cost price. The loss over the original price, over the cost price. Multiplied by 100. So see those questions similar. Let's see what it is up here. All right, same question we did over here. This question we did over here with the gas. You got the same question over here now with different values. So here now they tell you the fixed charge. So the fixed charge that we calculated over here a while ago, they are now telling us that the fixed charge is this. This is the same information, and they kind of spin around the values. It says a man pays 60 cents for every 200 meter cube of gas plus a fixed charge of 13.75. How much does he pay if he uses this amount of gas? So it's the same question. You're going to pay this amount, this. It's the same question, but let's see we have to work it out and can change the value. So he's going to pay, you're going to pay the gas charge plus the fixed charge. Which is this, right? What is the gas charge? The gas charge is total gas divided by the number of 200 in it times the 60 cents. So the total gas is 55,000 divided by 200. Want to know how much 200 in it? And multiply that now by 60 cents. So remember, you're going to change this to 60 cents. I think it's working. So multiply it by the 60. And plus the fixed charge of 13.75. Right? And you can realize this must be a whole number answer, you know. All the multiple zeros there. So the answer must have a 0.75 on it. So it must be the answer with a 0.75 on it. That this must be a whole number with all the multiple zeros that cancel. Look. So them zeros here, cancel them zeros there. Right? And then a 0 here turn this into a 3. No, turn this into a 6 first. 6. And that 2 here turn this into a 3. So you have 3 times 55. 165. That is 3 times the 50 first, make 150. 3 times the 50. In the 50, 3 times 55 now we're doing. So 3 times the 50 first is 150. And 3 times the 5 is 15. That's it enough. Plus this amount. Must be an answer with a 0.75 on it. It's one of yours. The only answer with a 0.75. That is it. All right, that's it. Next question. This one for the table below, which shows rates chart for insurance company by a company. It says insurance company. It says housing is 25 cents per $100. Remember, the 25 cents is dollars is $0.25. And 50 cents is half a dollar. $0.50 for every $100 content insurance. All right. It says, how much will a person pay for insurance if his house is valued at 50,000 and his content is 10,000? Now, first you want to know how much $100 in that. So see, you know, It's 50,000 divided by 100. But each of these 100s is paying this 25 cents. That's for the housing insurance. Plus, content insurance total is 10,000. Want to know how many $100 is in that? So divide by 100. And then for each $100 paying 50 cents, which is $0.50. That's what you're working out. That's what you're working out. Can us work this down? So you know, watch this now. This cancel this 2 times. Watch this now. See them 2 zeros here? I turn this into 25. See that? See that? And they're doing 5 times 25. 5 times 25 is how much? 125. 4 times 25 is 100. 5 times 25 is 125. Plus, over here, some now. This one kind of easier. Because this again, them 2 zeros here cancel them 2 zeros here. Them 2 zeros here turn this into 5. So that is $5. It's $5. Yeah, turn that into 5. It's $5. All right. All right. $50 that turn. Let's go again. Into. Let's go again. Let's go again. Let's go again. Let's go again. 2 zeros here. 10,000. Them 2 zeros here cancel them 2 zeros here. Or turn to the 50. Them 2 zeros here turn this into 50. 1, 2. Not 5. Turn it into 50. Turn this into 50. 50. So 1 times 50 is 50. That's 50. So 125 plus 1 plus 50 is 175. That's it. So remember, don't work in the cents, guys. Change the cents to dollars, all right? All right, let's go. All right. Let's 10 cents. Simple interest on a sum of money invested at 5% per annum for 3 years is $90. Sum of money invested is what? Asking for the principal. Sum of money invested is asking for the principal. Remember, I equals PRT by 100, right? The simple interest on a sum of money invested for 5 years. So this is the rate. The rate for 3 years. This is the time. Is $90. This is the interest. You're trying to find the principal. So you're going to multiply the 100 up here. 100 times I. Divide that by the rate and the time. Over the rate and the time. That leaves you with the principal. And put all these values in there and put this calculation up here instead. So this becomes that the principal is 100 times the interest of $90 divided by the rate of 5 times the time of 3. What is your report? That becomes the principal. You cancel this down. So 3 into this goes 1 time, 3 into this goes 30. 5 into this goes 20, right? Goes 2 times 20. So 20 times 300 is 600. That's 600. That's that. Next one. 7,000 bar at a rate of 5% per annum for 3 years. Simple interest is same thing. I equals PRT over 100 straight. Equal. The principal is 7,000. Let's put the value to the dollar sign. 7,000 times the rate of 5% and the time of 3 divided by 100. So we'll multiply these 3 values. So materially, it becomes 7 times 15. 7 times 15. So 7 times 10 is 71st, and 7 times 5 is 35. 105, right? 105. This value, you know. This value. I will put down about the zero. This how much zeros we have. Cancel that. Yeah. So 70 times 15. That's 7. 70 times 15. 70 times 15. So it becomes 10 times 7 times 15. So it's 10 times 70 plus 35. So we'll pump this one down and stuff. What? One value is 70 times 16. You want to do this enough, no problem. It could be 10, it could be 10 times, could do 10 times 71st, could do 10 times 70, and then 5 times 70. You want to do 10 times 70 is 700, and the 5 times 7 is 350. Same thing. Add them up to get 5010. Right? So anyway, you want to go, that is it. So next one says a dress cost $180 will be sold at a discount of 10%. The amount of the discount is 10%. Eh? 10% is $18. 10%. Just take off a zero, right? 10% times $180. It's 18. Same thing here. So a dress is cost 18,000. So it's $180. No, it's 18,000. Being sold at 10%. No, it's $180, right? So no, 10% of 1,800. 10% times 1800. That's this one now. Right? Same question, but stick another zero on it. So we have left. So much question we have left. Just run through them quickly. This one said cash price on a refrigerator at 1850. A buyer who is given a discount of 5% for cash purchase will pay, gonna pay 95%. Right? Gonna pay 95%. If you want to work with what 5% is and subtract it, you can do that as well. It's gonna pay 95%. And the cost of a refrigerator at 1850. $1,850. A buyer is given a discount of 5% for a cash purchase, which is gonna pay 95%. But you could work out the 10%, like so 10% is take off one of this to get that $185. So 5% is half of that, right? 5% is half of that is about half of 180, 90, $92.50. Half of 180 is 90. Half of the $5 is 250. So you're subtracting that from this amount. So it pays 1850 minus 92.50. That's what it's taking off. What are we looking for? See? Well, what I did this way. It can't be this, and it can't be that, right? But you have some zeros on it, don't it? And it can't be this either, but it's actually more, don't it? It have to be the C. So you could use a process of elimination like C. Let's use it. If TT $6 is equivalent to US $1, then TT 15 is how much? So you want basically you can do this as a ratio. ET to US is 6-1. You want this reach 15. See? 2.5 times. Swat it. Huh? Wanna get it? All right, so I said $12 is 2. $10 is 2. And $3. $3 is 50 cents. 0.5. So you add them two, don't it? You see that? If $6 is 1, you multiply by 2, you get $12 is 2. And then $3, half of this amount, is this. 12 and the 3 make 50. So the 2 and the 50 cents make $2.50. So anyway you want, I mean, at the end of the day, this is that. Right? That's it. All right. $2.50 equivalent to that. Then EC does. So see here now, we have 250. EC 1. And I try rush me. $2.50 is 1. Why not say 8? The more you know say 8. The more you know say 8. Why you don't forget to we reach 8. Why you get to be 8? You divide $2.50 into 20. I watch this now. I multiply it by 2 first. And build it up to 20. I multiply by 2, you reach 5 to 3. First, right? The more it's become 20 multiplied by 4. For to reach 20. When this side reach 20, this side reach 8. See it? So it's 8. Treat like a ratio. Let's build it up gradually. Understand? Build it up gradually. All right, this one. At the end of a year, a car is worth 95. If 5 is worth 5%. We do that question already, right? A car is worth 5% less than it was worth. Answer was 10,000. Huh? 10,000, same question, right? This one. And then I your car is worth 5% less than it was worth at the beginning of the year. Oh, this one, them double the value. They double the amount of value. See that? So 20,000 now. Same calculation as the one that we did at the top. So we double the value. Trying to move like it faster now. I will still have 2 pages to go. 3 pages. That so consumer arithmetic is a lot, I told you. Oh, the question is similar, we cannot skip over it. A cost present value is $12,000, is depreciated rate of 10% per annum. What will be the value of a car after 1 year? 90%. Eh? 90%. So materially, you multiply 9 times 12. The answer will 108 in it, don't it? See it? It's 90%. 90 over 100 times 12,000. I take off 10%. That is the value. So you multiply 9 times 8. See that? Materially, you multiply 9 times 8. So 108 are the material values. 9 times 8, so it has to be this. And 9 times 12. These are the values that are important in this calculation. And 9 times 12. 9 times 8. 9 times 12. So 108. Right? Other zeros work out themselves. All right? Next one. The annual interest rate on a mortgage. All right. On a mortgage on a house. Assessed to be valued at $450,000. It's 5% for every $1. What is the interest paid on a mortgage for the first year? Again, you're going to multiply 5 times 45. Material, those are the values that are important. 5 times 45 are the values that are important. See it? 5 times 45 is how much? 225. That's all. The answer must be this. Right? Because the 5 cents is never dollar become this. If we're working it out. The 5 cents is never dollar, right? So the 5 cents is $0.05, right? And every dollar, there are 455,000 of them. So you really multiply 0.05 times 450,000. For every dollar, you have to pay this amount. And this amount of dollars that is there. So it's this time this. You balance on that? So materially, you're multiplying these values, the 5 times the 45, which give you this. That's it. Work out itself. The zeros, the small places, doesn't matter of where those values, you know, so you're getting 5 times 45 is 225. See there? 5 times 45 is 225. So it must be this answer right here. So yes, and that. Answer must be this one. So only value with 225. You don't have to work out everything names and facts. And says on the paper. Next one says, a dinner at a restaurant was advertised for $60 plus 18% tax. The total bill is what? If I add 18% on this. That's all. Or you can do 118%. It's 118%. I can say 60 plus 18 over 100 times the $60. That's the calculation. So it can't be this. That's all time. Let's work out. Let's work it out. So what is 18% of $60? So work out 18% of $60. We can do step by step. You know. You can say, all right, 10% is $6, don't it? 1% is $0.6. So 8% is $8.6, 48, $4.80. So you want 18%, you add them 2 years. You add the 10% and the 8%. Another calculation. So more about 18%, right? Of 60. Right? So we can say 10% is $6. So 1% is 0.6. Divide this by 100. Divide it by 10, you get 0.6. And so 8% is 8 times this. 6840, you get $4.80. Right? So the 18% was this plus this. So the 18% becomes $10.80. I add this and this. So it's at $10.80. So it becomes $60 plus $10.80. So it must be this one. All right, next one. It says, at a sale, each book was marked $3 off the original price. Daniel paid $46 for 2 books. All right. That had the same price. What was the original cost of 1 book? What the original cost of 1 book? 2 books in buy and get $3 off each. So when pay $6 and pay 2 books, let's look at it this way. 1 book for $23. You pay 2 books in buy. So 1 book for 1 book, he paid $23. And that's after getting $23, after getting $3 off, right? So therefore, original price is $26. Therefore, original price is $23 plus a $3 discount you can get, which is $26. 26. Right? That's that. Let's talk how much, let's work out for 1 book. So I pay $26 for 2 books, so I pay $23 for 1 book after getting a discount of $3. Around about the discount is how much it was before. $26. Okay, that's to 3 cents for every dollar I spent. That's to 3 cents on every dollar is spent. Every dollar spent is the sales tax. How much is paid as sales tax? A customer pay $1.96. All right. 3 cents in every dollar, right? So that's $0.03 per $1. For every $1. So I multiply this by 0.03 to say so what the tax is for that amount, right? So that will be the tax becomes 196 times 0.03. 196 times 0.03. What I report to? 3 times the 196 is how much? Materially, for them figures are different. 3 times 196 is how much? 3 times 196. So it's 3 times 100 is 300. I'm going to divide by 100 after. Plus 3 times 90 is 270. 270. And 3 times 6 are 80. So it's 588. So it must be that one here. See that? Because the 0.3 and I'm going to divide it by, I'm going to think about this 0.03. So that is it. 588. Let's multiply it. So it's whatever plot of land, 18,000, the land charges, 10% for 100. What is the total amount paid for land tax? We did that question already? Are we done this question? All right, total value of land is that. So, all right, so I want to know how many $100 is in this. I'm going to pay 70 cents for every one of them. So it's $18,000 divided by the $100 to see how many 100 is in there times 70 cents. So materially, you're multiplying 7 and the 18. Must be the answer with the end with a 6. Has to be this one. At 7 times it is 56. Huh? Similar, yeah. Has to be that one. Next question. Mr. Jones bought a car for $64. Car depreciates at 20% for the first year and 10% in each of the following years. The value of the car at the end of the second year is what? So if you depreciate it by 20%, means that it's 80% its value after the first year, right? Let's set up this way. So year 1, and then year 2. So year 1, the value becomes 80% of the 64,000. That's the value after year 1. And you're applying 10% to this value. And then depreciate it by 10, no, not 10, but 90%. Depreciate by 10%, so it becomes 90% times that value. That is it. That's what you're working on. Understand the calculation? This is the value after 1 year, 80% of what it was. So this is the value after 1 year, 80% of the original. And then you're taking off 10% of this value now. So it becomes 90% of that. That's the calculation. So materially now, you're multiplying 9 times 8 times 64. That's why you multiply. 9 times 8 times 64. Whatever digits those give you, one of these answers is your answer. Huh? 4608. Those are the values. So you will multiply into which are the values? 9 times 8 times 64. Material goes on the bottom. You understand the calculation here, sir? Right? So the 9 times 8 is 72, don't it? So you're really doing 72 times 64. That's what you're working on. Right? 72 times 64. That's what you're working on. So you said the P1, this one. So you work that out. 72 times 64. And you get the material value for that. So the 2 times 8, 2 4 is 8, 2 6 is 12, right? Then it says 7 4 is 28. That's 0, yes, so. And then you go 7 4 is 28. 7 6 is 42. 42 and 2 make 44. So you get 8 0 1 make 6 4. That's what it becomes. So that's why this is the answer. And the 0 them take care of themselves. But digit wise, this is the answer looking for 4608. Alright, now how about everything, guys? This one. Plot of land is valued at $18,000. Plot of land. Land tax is 126 is charged annually. At what rate per annum is the land tax? So it's 126 out of the 18,000 times 100. I say that, so you're working out. So the tax over the value times 100. See that? That's what you're working out. So these two zeros cancel this. And they're working what this is now. That's a 0.7, you know. Now this will reach 1. 126 over 180. Can't reach 1, so almost 0.7 is the answer. All right? Am I correct? Can I say that must be 0.7? All of these values are 7, right? I can't have 7 because you see the two zeros cancel here, so I ended up with 128 over 126 over 180. Must be 0.7 that. Must be 0.7. All right, so that fraction of the 180. Next one. So the exchange rate for $1 United States is $2.70 Eastern Caribbean. 270. What is the value of 450? So basically multiply these, right? Multiply 4.5 times 270. That's all. It becomes 4.50 times 270. That's what you multiply. 4 times 1.5. So D. All right. But it has to be. You can look at it and know. If it's 4 times this already, you're gone over 8. Don't it? So you can't be none of D. It's out of it. Right? Because 4 times this alone gone over 8 already. So it has to be D. So again, as you look at the answer, just see. You can eliminate. Man, I was selling 45,000. His tax free allowance is 13,000. He has to pay a tax of 20% of his taxable. The tax paid is what? So he pay taxable becomes 45,000 minus 13,000. Understand that? His salary is 45,000. The tax-free allowance is 30. In other words, subtract that first to see what the taxable is. So 45 minus 13 is how much? 32. 32,000. And now you want 20% of that. So the tax becomes 20% of 32,000. 2 times 32 is 64. So sum it 64. See there? 2 times 32 is 64. So that's all the answer that is for it. Has to be that. So a television set cost $350. When bought on higher purchase at the deposit of $35 squared plus 12 monthly payments of total, how much is saved? The question is popular, right? So it's gonna pay $35 plus 12 times $30. That's $35 plus $306, right? So it's gonna pay $395. Pay the scale. We're gonna save $395 minus $350. Gonna save $45. All right, that's an easy. Over here. It says the annual interest rate of 50 and a 15-year mortgage and a house is assessed to be 450. The same question this. B again, right? We're actually doing 0.05 times 450,000. So this again, right? Material we're multiplying 5 times 45. It's 225. Material, that's all I'm going to do. All right. We're invested $200 for 5 years, 5% per annum. John invested $500 at the same rate. If they both receive the same amount, a simple interest, how many years did John invest? All right. So yeah. So PRT over 100, Mary must equal PRT over 100 for John, right? So this is for Mary. This is for John. All right. So the PRT over 100. So for Mary, it is 200 times the rate of 5 for 5 years over 100 for Mary must equal the same interest for John. And John invested $500 for the same rate of 5% for a time that we don't know, divided by 100. I'm trying to find the time, right? Time is going to be 2. But everything cancel out. This cancel with this. A 5 I cancel with a 5 there. Right? A 5 until it goes 1 time. A 5 until it goes 100. 100 goes 1 time. 100 into that goes 2 times. So time equals 2. 2 years. Right? 2 years. You basically equate the 2 interest then and cancel it out. So the time equals 2. That's the only thing that is left. So a salesman sells a car for $11,000. He's paid a commission of 4.5% for the first 10,000, 7.5% for the remainder. His commission received is what? So he's paid 4.5 over 100 for the first $10,000. Plus, he's paid 7.5, but the remainder is going to be 1,000, right? If we take out 1,000, you have 1,000 left. So he's paid 7.5 over 100 for the next $1,000. Just $1,000. That's what we're working out. That's what we're working out. So cancel this out of that. 100 times that give you $45. That's $45. Plus, over here, this cancel that. Yeah, this is gonna $75. That's right though. It's not 45, that's 450. 450 years. So 100 times is 450. Then you're adding $75. Compare by 10. So you're adding $75 over here. So it's 450 plus 75. How much is that? 525, right? 525. 525. 2 o'clock. Finish up this and then we're done. Finish up this and then we're done. What time is it we're finish? 1 o'clock? Get that or extra. It's all right. A salesman says that car for 10,500. If he's paid a commission of 5% at per 10,000, 8% and remainder. Same calculation this is now. It's 5 over 100 for the first $10,000 plus 8%. 8 over 100 for the remainder. The remainder is 500 times $500. That's what we're working on. Let's cancel out. So it's 100 to that, 100 to that. 5 times 100 is so it's $500. Plus over here is 8 times 4 is $40. Listen to this. 8, 5, 40. It's $40 more. So it's paid $540. What's that? Next one. A company employs 20 persons as gardeners and clerks. The mean daily wage of all employees is $22.40. If each of the gardeners is paid $26 per day, then the daily amount paid by the 8 clerks is what? So we want to work for the average rate, the average for this. So the average is going to be 12 times $26. That's a total payment. Total payment is 12 times $26 plus 8 clerks times the amount that they are paid is X. They don't know X. They don't know the daily rate. Trying to find X. Divided by 20 persons. That's a total pay for all of them. Divided by 20, that averages $22. $22.40. That's why you're working on for X. This will be the total pay over the 20 people averaging that. So first we're going to multiply this over here. So 20 times that. So the 12 times X. 12 times is how much? 12 times 26 is 10 times 26 is 260. And then 2 times 26 is 52. That becomes 211. That's 312. That becomes 312. That's right. 10 times 20 is 260. 2 times 20 is 52. 2, 11, 312. That becomes 312. $312 plus 8 times X equal. Multiply this across here now. 20 times this. So the 10 we're moving sales of first. Make it 224 times 2, make it 448. $448. After this without a calculator, guys. They're gonna subtract. So 8x is gonna equal to 448 minus 312. 448 minus 312. How much is that? 631. 136. 136. So x equals 136 divided by 8. How much is that? 136 divided by 8. What I record with? Yeah, but $17. $17 is the answer. 16 easy enough. Got them calculation now. You have to do the calculator. We just divide it out. The landlord invests $5,000 for 2 years at an interest at an investment scheme. The investment earns a compound interest of 8% per annum. What will be the amount of the learner's investment at the end of 2 years? So it's gaining 8%. So let me see these answers. So one of these two is the answer, right? One of those two is the answer. Let's look at it. So it's gaining 8%. So watch this now. The first year, look at this way again. Year one, and then year two. So in year one, the amount accumulated is going to be 108 over 100 times the 5,000. And then on top of that, you're going to add another 108%. So it becomes 108% over 100 times. So it's the accumulated amount after the first year. They added 8%. And then now this is the accumulated amount. You multiply this out, get the second year. The question is, what was the first year work out to? 108%. So we added 8% to 5,000. So 8%. So 10% is 500. Oh man. So 1% is 50. So 8% is 8,540, right? 400. So this becomes 5,400. Senior is 5,400. Then now you're doing 108% of this now. So you're doing 108% of this. So 10, so we're going to see everything again of this now. In this one. So 10%. Once which one of them if you jump over this one. It have to jump over this one now. It have to be this one. It have to be the last one. Because look here. If you added 400 in the first year, you can't add 400 again in the second year. You're gonna add more. See? So the answer has to be the last one. It's not 400 more you got add. If you added 400 in the first year, we add 108, we add 8%. Second year, you have to add more. I added now 8% on top of this. So it has to be this answer is the correct. It can't be another 400 they added. So the answer has to be this one. So we don't have to report on this. That is it. You don't have to report on it more. One last question, and we'll call it a day. So we're gonna do those other papers some other time, right? So Megan normally saves X dollars per month. We do this question all the while. Right, but in August she saves $4 less than twice her usual amount. So it's 2x minus 4. 2x less 4. This is the answer for this one. All right, guys, that is it. I'm not going to do that with them. We do those after we finish this little thing. So tomorrow come back, try to we can keep it within the time frame. All right, but that is it. That is it. I went to our real fast. I went 20% salon. All right, guys, online, that is it. I'm going to share the recording afterwards. All right. Bye, guys. I'm going to end the session now.